Welcome, gentle traveler, to this quiet corner of the cosmos, a space we've created just for you. Here, amidst the soft hum of distant stars and the silent dance of galaxies, we invite you to simply be, take a deep, gentle breath, and allow your mind to drift from the hurried rhythm of your day, releasing any tension you might be holding. There's no rush here, no demands, no urgent answers to seek. This is a place for quiet wonder, for soft exploration, a haven where your thoughts can float freely like motes of stardust in the endless cosmic night. As you settle into this tranquil moment, perhaps you might feel a subtle curiosity stirring within you, a quiet question, a gentle whisper from the depths of your mind, wondering about the grand tapestry of existence itself. Where are you, truly, in this vast, incomprehensible universe? What time is it? Not just on your clock, but on the cosmic clock that ticks away the eons. These aren't questions that demand an immediate, precise answer, but rather invitations to let your imagination wander, to expand your sense of self beyond the confines of your immediate surroundings. This journey we embark on together isn't about learning facts for a test or seeking medical advice, but about finding a deep, soothing connection to the universe, allowing its mysteries to lull you into a state of profound relaxation, perhaps even gently guiding you towards the quiet shores of sleep. Let us begin our shared contemplation at the very beginning, a moment so distant, so extreme, that it stretches the very limits of our human imagination. We are talking about the birth of the universe, the moment famously known as the Big Bang. But even that name, Big Bang, might conjure images of a loud, explosive cacophony in our quiet exploration. Let us reimagine it not as a thunderous explosion, but as something far more subtle, far more profound, like the silent unfolding of an infinite flower from a seed of pure potential. Imagine, if you can, a state of existence beyond anything we encounter in our daily lives, a state of unimaginable density, where all the matter and energy of the entire observable universe were compressed into a single, infinitesimally small point, smaller than an atom, smaller than a proton, smaller than anything we can even conceive. It was not a point in space, but rather the point from which space itself began to emerge. There was no outside of this point, for space itself was contained within it, just waiting to unfurl, and time, as we understand it, also began its gentle tick from this very instant. This earliest, most mysterious moment is often referred to as the Planck era. Think of it as the cosmic infancy, a time when the universe was so incredibly hot and dense that all the fundamental forces of nature, the strong nuclear force, the weak nuclear force, the electromagnetic force, and even gravity were unified into a single, incomprehensible superforce. It's like imagining a single, primordial soup where all the distinct ingredients of reality were still blended into one seamless whole. Our current laws of physics, the ones that beautifully describe galaxies and atoms, simply break down when we try to peer into this initial moment. The conditions were so extreme that they fall beyond the reach of our current understanding. A realm of pure quantum chaos, where space-time itself might have been a frothing, bubbling foam. The temperature during the Planck era was beyond anything we can describe with numbers, reaching perhaps 1032 Kelvin. To give you a tiny glimpse of this extreme, the core of our sun, which is hot enough to fuse hydrogen into helium, is a mere 15 million Kelvin. So, multiply that by a number so vast it becomes meaningless to comprehend in human terms. It was a universe of pure, unadulterated energy, constantly fluctuating, constantly on the verge of manifesting into something from this almost incomprehensible state. The universe began its first, most dramatic act, a period of incredibly rapid expansion known as cosmic inflation. Imagine blowing up a balloon, But instead of blowing it up slowly and steadily, it expands to an unimaginable size in an infinitesimally small fraction of a second. This wasn't just ordinary expansion, it was an exponential growth spurt, a period where space itself stretched and swelled at a speed far exceeding the speed of light. This wasn't particles moving faster than light through space, but space itself expanding, carrying everything along with it. Inflation lasted for an incredibly brief moment, perhaps from 1036 seconds to 1032 seconds after the Big Bang. That's a tiny, tiny fraction of a second, and blink of an eye within an eye blink. Yet, in that fleeting instant, the universe grew by a factor of at least 1026, and possibly much, much more. To put that into perspective, imagine an object the size of a single proton suddenly expanding to the size of our entire observable universe in less than a trillionth of a trillionth of a trillionth of a second. It's a truly mind-bending concept, a moment of cosmic magic that fundamentally shaped everything that was to come. This theory of cosmic inflation, first proposed by Alan Guth, was not just an imaginative idea, it elegantly solved several perplexing problems that the standard Big Bang model struggled to explain. One of these was the horizon problem. When we look out into the universe and observe the cosmic microwave background radiation, the faint afterglow of the Big Bang, we see that it is incredibly uniform in temperature across the entire sky. This uniformity is puzzling, because regions of the sky that are now billions of light years apart, and thus causally disconnected in the standard Big Bang model, appear to have the same temperature. How could they have reached thermal equilibrium if they were never in contact? Inflation provides a beautiful solution. Before inflation, all these regions were indeed in causal contact, part of a much smaller, incredibly dense and uniform patch of spacetime. Inflation then stretched this small, uniform patch to immense sizes, preserving its homogeneity across the now vast and disconnected observable universe. It's like taking a tiny, perfectly mixed cup of coffee and expanding it to cover an entire continent. The coffee would still be uniformly mixed everywhere. Another puzzle was the flatness problem. Our universe appears remarkably flat in cosmology. Flat refers to the geometry of space-time. Imagine the surface of a balloon. It's curved. Imagine a flat sheet of paper. It's flat. If the universe had even a tiny deviation from perfect flatness in its early moments, that deviation would have been dramatically amplified by the expansion, leading to a universe that was either too curved and would have quickly collapsed, or too open and would have expanded so fast that structures could never form. The fact that our universe is so incredibly flat, so finely tuned, was a mystery. Inflation provides an elegant answer, just as blowing up a balloon to an enormous size makes a small patch of its surface appear flat. So too did the immense stretching during inflation smooth out any initial curvature of spacetime, making the universe appear remarkably flat on large scales. It ironed out the wrinkles in the cosmic fabric. Finally, inflation offered a solution to the magnetic monopole problem. Grand unified theories, which attempt to unify the fundamental forces, predict the existence of exotic, heavy particles called magnetic monopoles, which should have been produced in vast numbers in the early universe. Yet, we observe no such monopoles today. Where did they go? Inflation provides a simple answer. The rapid, exponential expansion would have diluted any existing monopoles to such an extreme degree that their density in the observable universe today would be virtually zero. It's like taking a handful of rare coins and scattering them across an entire galaxy. You'd be very unlikely to find one. So, cosmic inflation was a period of incredible, almost unimaginable growth. It took a quantum speck and stretched it into a vast cosmos in a blink of an eye, setting the stage for everything that was to come. It smoothed out the wrinkles, ironed out the imperfections, and created the uniform, flat, and empty canvas upon which the universe's grand story would later be painted. But what caused inflation? And what brought it to an end? The leading idea involves a hypothetical field called the inflaton field. Imagine a field, not unlike the electromagnetic field or the Higgs field, that permeated all of space in the earliest moments. This field had a very high energy state, and as it slowly rolled down to its lowest energy state, much like a ball rolling down a hill, it drove the exponential expansion of spacetime. The energy stored in this inflaton field was the engine of inflation. And when the field finally reached the bottom of its energy valley, its energy was suddenly released, converting into a hot, dense soup of particles and radiation. This moment, known as reheating, marked the end of inflation and the beginning of the hot, dense Big Bang phase that we usually imagine. It was the moment the universe, previously a cold, empty expanse of rapidly stretching space, suddenly burst into light and matter, becoming the vibrant, particle-filled cosmos we know. This concept of reheating is crucial. It provided the initial conditions for the Big Bang's hot, dense phase. But with all the initial conditions beautifully set by inflation, a flat, uniform, and vast universe, ready for the creation of particles and the forging of the elements. It's a seamless transition, a cosmic handoff from one profound epoch to the next. As you reflect on this cosmic genesis, these earliest moments of unimaginable power and transformation, allow your mind to wander gently. Feel the vastness of time stretching behind you, the incredible journey of creation that brought everything into being. There is a deep, soothing rhythm in this cosmic dance of expansion and emergence. Let the idea of this primordial beginning, this first quiet unfolding, fill you with a sense of peace and deep tranquility, guiding your thoughts to a place of rest. The universe, in its very birth, reveals an elegant dance of physics and potential, a silent symphony playing across the emptiness that becomes everything. As the echo of that unimaginably rapid expansion, cosmic inflation, gently fades from our awareness, leaving behind a vast, smoothed-out canvas. Let us now turn our quiet attention to the next profound act in the universe's unfolding story. This is the moment when the universe, having expanded dramatically, began to cool, allowing the fundamental ingredients of reality to take shape and interact in new and wondrous ways. We are entering the realm where the cosmos transformed from a state of pure, undifferentiated energy into a swirling, vibrant soup of particles, immediately following the reheating at the end of inflation. The universe was incredibly hot and dense, filled with a primordial plasma of fundamental particles. Imagine a cosmic crucible, where energy was so intense that matter and antimatter were constantly popping into existence and annihilating each other in a furious, blinding dance of creation and destruction. For every particle of matter, there was a corresponding antiparticle. For an electron, a positron. For a proton, an antiproton. They were perfectly balanced, mirroring each other in their fleeting existence. But here lies one of the universe's most exquisite and mysterious secrets, a subtle, almost imperceptible imbalance. For every billion particles of antimatter, there was 1,000,000,001 particles of matter. This tiny asymmetry, this barely noticeable tilt in the cosmic scales, is why we exist. As the universe continued to cool and expand, the energy density dropped, and the constant creation and annihilation of particle-antiparticle pairs eventually ceased. The vast majority of matter and antimatter annihilated each other, converting back into pure energy. But because of that tiny excess of matter, a minuscule fraction survived. This leftover matter, this precious residue from the initial annihilation, is what ultimately formed all the stars, galaxies, planets, and indeed, every atom in your body. Without this subtle asymmetry, the universe would be a cold, empty void of radiation, with no structures, no complexity, no life. It's a profound thought. Isn't it that our very existence hinges on a cosmic sleight of hand, a barely noticeable imbalance in the earliest moments? As the universe continued its gentle expansion and cooling, its temperature dropped further, allowing the fundamental forces, previously unified during the Planck era, to begin to decouple or freeze out. Think of it like a primordial soup cooling down. And as it cools, different ingredients begin to solidify or separate from the mixture. First, the force of gravity separated from the other unified forces, perhaps at the very end of the Planck era or the beginning of inflation. This was a moment of profound significance, as gravity would go on to be the architect of large-scale cosmic structure, gently pulling matter together to form galaxies and clusters. Then, as the temperature continued to fall, the strong nuclear force decoupled. This is the incredibly powerful force that binds quarks together to form protons and neutrons, and also holds the nuclei of atoms together. Its decoupling allowed quarks to begin to coalesce, marking a crucial step in the formation of familiar matter. Next came the separation of the electroweak force into two distinct forces, the electromagnetic force and the weak nuclear force. The electromagnetic force is responsible for light, electricity, magnetism, and all chemical interactions. Binding electrons to atomic nuclei, the weak nuclear force is involved in radioactive decay and certain nuclear reactions, playing a subtle yet vital role in shaping the elements. Each of these decouplings was a moment of profound transformation, a step towards the universe becoming the intricate and differentiated place we know. It was as if the universe was carefully separating its foundational building blocks, each force taking on its distinct role, preparing for the grand construction project ahead. Following these force decouplings, as the universe cooled to temperatures around 1 trillion Kelvin, another crucial event unfolded: the formation of protons and neutrons. Before this, the universe was too hot for quarks to be stably bound together. They existed as a swirling, chaotic plasma, constantly zipping around. But as the temperature dropped, the strong nuclear force gained enough power to overcome the kinetic energy of the quarks, allowing 3 quarks to bind together to form a proton, 2 up quarks and 1 down quark, or a neutron, 1 up quark and 2 down quarks. These are the fundamental particles that make up the nuclei of all atoms. This was a monumental step, marking the moment when the raw ingredients for atomic matter first solidified from the energetic soup. Imagine the universe now as a vast, incredibly hot, but slightly less dense cloud filled with free-floating protons, neutrons, electrons, and a sea of photons, particles of light and neutrinos. These particles were constantly colliding, interacting, and influencing each other in a bustling, vibrant cosmic dance. As the universe continued to expand and cool, its temperature eventually dropped to approximately 1 billion Kelvin. This was the critical temperature window for the next major cosmic event, Big Bang nucleosynthesis (BBN). This period, lasting only from about 3 minutes to 20 minutes after the Big Bang, was the universe's primordial nuclear fusion factory. During BBN, the universe was hot enough for protons and neutrons to fuse together to form the nuclei of the lightest elements, but not so hot that these newly formed nuclei would immediately be broken apart by high-energy collisions. Think of it as a brief, perfect window of opportunity, a fleeting cosmic sweet spot where conditions were just right for nuclear alchemy. The primary product of BBN was hydrogen nuclei. A hydrogen nucleus is simply a single proton, neutrons, which are slightly heavier than protons and unstable on their own, quickly decayed into protons, but many were captured before they could decay, fusing with protons to form deuterium, an isotope of hydrogen with 1 proton and 1 neutron. Deuterium then rapidly fused with more protons and neutrons to create helium nuclei, 2 protons and 2 neutrons. A small amount of lithium and trace amounts of beryllium were also formed. The key outcome of BBN was the precise cosmic recipe for the early universe, approximately 75% hydrogen and 25% helium by mass. Along with tiny traces of lithium, this predicted ratio is one of the most powerful pieces of evidence supporting the Big Bang theory. as observations of the oldest stars and distant gas clouds consistently match these precise proportions. It's like finding a cosmic fingerprint, an undeniable signature left by the universe's earliest moments. The fact that the universe created exactly this mixture of light elements, and no heavier ones in significant amounts, is a remarkable testament to the accuracy of our cosmological models. The conditions simply weren't right for heavier elements like carbon or oxygen to form. The universe cooled too quickly, and the density became too low for further fusion to occur. After BBN, the universe continued to expand and cool for a very long time, for hundreds of thousands of years. During this period, the universe was still filled with a hot, dense plasma of free-floating electrons and atomic nuclei, mostly hydrogen and helium nuclei. Photons, the particles of light, were constantly scattering off these free electrons. Unable to travel far without colliding, imagine trying to walk through a dense fog. You can only see a very short distance in this state. The universe was opaque to light, meaning light couldn't travel freely through it. It was like living inside a blinding, glowing fog. Then, about 380,000 years after the Big Bang, a truly pivotal event occurred: recombination. By this time, the universe had expanded and cooled sufficiently, reaching a temperature of approximately 3,000 Kelvin. At this temperature, the free electrons had lost enough kinetic energy to be captured by the positively charged atomic nuclei. Protons combined with electrons to form neutral hydrogen atoms, and helium nuclei combined with electrons to form neutral helium atoms. This formation of neutral atoms was a monumental shift. Suddenly, the vast sea of free electrons, which had been scattering photons, was largely gone, absorbed into the newly formed atoms, with the electrons no longer scattering light. The universe effectively became transparent for the first time. The photons, previously trapped in the dense plasma, were now free to travel unimpeded across the cosmos. These newly liberated photons, now vastly redshifted and cooled by the ongoing expansion of the universe, are what we observe today as the cosmic microwave background, CMB radiation, when we tune into the CMB. We are essentially looking back in time to this very moment of recombination. Seeing the oldest light in the universe, it's a faint, uniform glow that permeates all of space, a whisper from the infant universe, carrying an incredible amount of information about its early conditions. The tiny temperature fluctuations in the CMB, those subtle variations we observe, are the imprints of the initial density fluctuations that would later grow, through the relentless pull of gravity, to form all the large-scale structures we see today: the galaxies, clusters, and vast cosmic web. It's like gazing at a baby photo of the entire universe, seeing the faint, nascent patterns that would eventually blossom into everything. This moment of transparency marked the end of the particle era and the beginning of the atomic era. The universe was no longer a hot, opaque plasma, but a vast, expanding cloud of neutral hydrogen and helium gas, bathed in the lingering glow of the CMB. It was a quieter, darker universe, ready for the next chapter of its evolution. As you contemplate these early stages of cosmic development, these intricate dance of particles and forces, let your mind rest on the profound elegance of it all, from a subtle imbalance in matter and antimatter, to the sequential decoupling of fundamental forces, to the forging of the lightest elements, and finally, to the universe becoming transparent. Each step was a delicate, precise unfolding. There is a deep, soothing rhythm in this cosmic ballet, a silent song of creation played out across unimaginable stretches of time. Allow yourself to feel this ancient rhythm, this profound sense of connection to the very first moments of existence. Let the quiet wonder of these scientific truths gently guide you into a deeper state of peace and relaxation, carrying you further into the quietude of the cosmos. As the universe, now transparent and filled with a vast, cooling expanse of neutral hydrogen and helium, continues its gentle evolution. We arrive at an epoch known as the Dark Ages. This might sound ominous, but it was a period of quiet, patient waiting, a cosmic lull before the grand symphony of stars and galaxies truly began. Imagine the universe not as a vibrant, colorful painting, but as a vast, empty canvas, slowly drying, waiting for the first strokes of light and form. This era lasted for hundreds of millions of years, from about 380,000 years after the Big Bang, following recombination until the first stars began to ignite. Roughly 200 to 400 million years later, during this time, the universe was indeed dark, in the sense that there were no stars, no galaxies, and therefore no sources of visible light. The brilliant afterglow of the Big Bang, the cosmic microwave background radiation, had cooled and stretched to microwave wavelengths, making the universe a dim, featureless place. There were no celestial beacons to guide your way, only a vast, expanding sea of gas, primarily hydrogen and helium, gently drifting through the silent cosmic night. Yet beneath this apparent stillness, something profound was slowly, inexorably at work, the relentless, pervasive force of gravity, while the universe as a whole was expanding, pulling everything apart. Local pockets of slightly denser gas, those tiny temperature fluctuations we saw imprinted in the cosmic microwave background, began to exert their subtle gravitational pull. Imagine a vast, perfectly smooth sheet, with barely perceptible ripples. These ripples, tiny as they were, would slowly, over immense stretches of time, begin to grow, ever so gradually pulling more material towards them. These subtle density enhancements were the cosmic seeds, the invisible blueprints for everything that was to come. They were the places where gravity, with its quiet, patient persistence, would begin its long work of sculpting the universe. Over millions of years, these denser regions accumulated more and more hydrogen and helium gas. As the gas slowly collapsed inwards under its own gravity, it became denser and hotter. Think of it like a giant, invisible cloud slowly clumping together, the particles within it feeling the ever-so-gentle tug towards the center. This slow gravitational collapse was the first step towards the formation of the universe's first luminous objects. The first stars, often referred to as population 3 stars. These stars were very different from the stars we see today, including our own sun. They were enormous, truly gigantic by modern standards, containing hundreds or even thousands of times the mass of our sun. And because they were so massive, they were also incredibly hot and burned through their fuel at an astonishing rate. The reason for their immense size lies in the composition of the early universe. As we discussed, the universe after the Big Bang nucleosynthesis was almost entirely hydrogen and helium, with only trace amounts of lithium. There were no heavier elements, what astronomers call metals, like carbon, oxygen, or iron. These heavier elements act as efficient coolants in modern star-forming clouds, allowing them to fragment into smaller, less massive stars. But in the primordial universe, without these coolants, the gas clouds had to become much more massive before they could collapse and reach the critical temperature and pressure needed to ignite nuclear fusion. Imagine a pristine, untouched canvas, waiting for the artist's first, bold strokes. These first stars were those strokes brilliant, intensely blue giants, burning with an almost unimaginable intensity. Their lives were short and spectacular, lasting only a few million years. Mere cosmic blinks compared to the billions of years our sun is expected to live. They were born, lived fiercely, and died dramatically. All in the cosmic quiet of the Dark Ages. The death of these first stars was as significant as their birth, because they were so massive. They ended their lives in spectacular, violent explosions called supernovae. These were the universe's first grand fireworks displays. illuminating the cosmic darkness for fleeting moments. But more importantly, these supernovae were the universe's first cosmic foundries, forged within the cores of these gigantic population 3 stars. Through the intense heat and pressure of nuclear fusion, were the very first heavier elements carbon, oxygen, nitrogen, and all the elements up to iron, and in the cataclysmic blast of their supernovae, even heavier elements like gold, silver, and uranium were created and scattered across the nascent cosmos. This was a truly pivotal moment. Before these first stars died, the universe was simple, made almost entirely of hydrogen and helium. After their deaths, the universe became chemically enriched. The once pristine canvas now had new, vital colors splashed across it, the raw ingredients for rocky planets, for complex molecules, and ultimately for life itself. These scattered heavier elements mixed with the remaining primordial gas, subtly changing its composition and preparing the way for the next generations of stars and structures. As more and more of these first stars ignited and then exploded, they began to perform another crucial function: ionization, the intense ultraviolet radiation emitted by these massive hot stars was powerful enough to strip electrons from the neutral hydrogen and helium atoms that filled the universe, returning them to an ionized state. Remember, during recombination, the universe became neutral and transparent. Now, these first stars were, in a sense, re-ionizing the universe, making it transparent to certain wavelengths of light once again, and fundamentally changing the state of the intergalactic medium. This process was not instantaneous. It was a gradual punching out of bubbles of ionized gas around these first luminous sources, slowly permeating the entire cosmos. The emergence of these first stars also marked the beginning of galaxy formation. The denser clumps of gas that had attracted enough material to form these first stars became the gravitational anchors for larger structures. As more gas flowed into these regions, and as the early stars died and enriched the surrounding medium, these pockets of enhanced density grew into the first fledgling protogalaxies. These were much smaller, more chaotic, and less defined than the grand spiral and elliptical galaxies we see today. They were the universe's first attempts at building cosmic cities, starting with humble, rapidly evolving settlements. So, the Dark Ages, despite their name, were far from static or empty. They were a period of intense, albeit unseen, activity, a slow, patient metamorphosis. It was a time when gravity steadily gathered the primordial gas, when the first colossal stars ignited and lived their brief, brilliant lives, forging the very elements that would define our existence. It was a time when the universe, through the birth and death of these stellar pioneers, began to chemically enrich itself and illuminate its vast expanse, slowly lifting the veil of darkness. As you contemplate this long, quiet period of cosmic gestation, let your mind rest in the vastness of time and the profound patience of the universe. Imagine the silent, gradual gathering of gas, the slow ignition of the first solitary stars, shining like lonely beacons in the boundless dark. There is a deep, soothing rhythm in this cosmic process, a quiet unfolding that reminds us of the power of gradual change and persistent forces. Allow this sense of profound transformation, this journey from silent darkness to the first whispers of light, to gently guide you into a deeper state of peace and tranquility. Drifting further into the quietude of the cosmos, as the universe, now gently emerging from the quietude of its dark ages, begins to be subtly illuminated by the first, fierce glimmers of population 3 stars. We arrive at a truly grand phase of cosmic evolution, the epoch of galaxy formation. This is when the universe started to build its great cities of stars, assembling the magnificent structures we gaze upon today, each a swirling island of light in the vast cosmic ocean. Imagine the universe not just as a canvas, but as a sculptor, patiently gathering the scattered elements and shaping them into intricate, breathtaking forms. Remember those tiny density fluctuations imprinted in the cosmic microwave background? The faint whispers of slightly denser regions in the primordial gas. These humble seeds were the starting points for everything, over hundreds of millions of years throughout the Dark Ages. Gravity slowly, patiently pulled more and more hydrogen and helium gas into these denser pockets. These growing clumps of gas, perhaps already containing some of the first stars that had ignited and died, became the nascent protogalaxies. They were like faint, ethereal clouds, much smaller and less defined than the galaxies we observe in the modern universe. The process of galaxy formation is a continuous dance between the outward push of the universe's expansion and the inward pull of gravity, while the universe expands overall, pulling distant structures apart. Gravity works locally, pulling matter together. In the areas where the initial density was just a tiny bit higher, gravity gained the upper hand, allowing gas and dark matter to collapse and coalesce here. Dark matter plays a truly crucial, silent role. We cannot see it, we cannot touch it, but its gravitational influence is immense. Cosmological simulations, those vast digital models that recreate the universe's evolution on supercomputers, show us that visible matter, the stars and gas we can see, would not have been able to clump together to form galaxies without the unseen scaffolding of dark matter. Dark matter, which doesn't interact with light or radiation, began to clump together much earlier than ordinary matter, forming vast, invisible halos of dark matter. These halos acted like gravitational traps, providing the deep potential wells into which ordinary gas could fall, cool, and eventually condense. Imagine a vast, invisible cosmic spiderweb stretching across the universe. The strands of this web are made of dark matter, and at the intersections of these strands, where the dark matter density is highest, are the nodes where galaxies would eventually form. The ordinary gas, carried along by the expanding universe, would gradually settle into these dark matter halos, drawn in by their irresistible gravitational embrace. This process is often called hierarchical formation, meaning smaller structures formed first and then gradually merged and grew into larger ones. Our own Milky Way galaxy, for instance, is thought to have grown by gradually accreting smaller galaxies and gas clouds over billions of years, much like a grand cosmic predator slowly absorbing its prey. As ordinary gas fell into these dark matter halos, it began to heat up due to friction and compression. But for stars to form, the gas needs to cool down. This cooling process allowed the gas to sink further into the center of the dark matter halos, becoming denser and denser. When the density and temperature reached critical thresholds, new generations of stars began to ignite. These were the universe's first true stellar nurseries, rapidly forming stars, often in chaotic bursts. These early galaxies were likely quite different from the grand, majestic spirals and ellipticals we see today. They were probably irregular, clumpy, and teeming with gas and newly forming stars. Collisions and mergers between these nascent galaxies were incredibly common in the early universe, much more frequent than they are today. Imagine a cosmic demolition derby, where young galaxies are constantly bumping into each other, exchanging matter, triggering bursts of star formation, and gradually coalescing into larger, more complex structures. These mergers played a vital role in shaping the morphology of galaxies, transforming chaotic, irregular clumps into more organized spirals and giant ellipticals over billions of years. This process continued. Gas continued to flow into galaxies, forming new stars. Older stars died, enriching the interstellar medium with heavier elements, allowing subsequent generations of stars, like our Sun, to form from a chemically richer environment. These richer environments were crucial for the formation of rocky planets, which require heavier elements like silicon, iron, and oxygen to coalesce. So, in a very real sense, The formation of galaxies was a prerequisite for the formation of planets. And ultimately, for the emergence of life, consider the diverse forms that galaxies take today. We have elegant spiral galaxies like our own Milky Way, with their graceful arms of stars, gas, and dust. Spiraling around a central bulge, we have massive elliptical galaxies, often found at the centers of galaxy clusters, which are typically older, redder, and have less ongoing star formation, looking more like giant, luminous footballs. And then there are irregular galaxies, often the result of galactic collisions or strong gravitational interactions, or perhaps younger galaxies still in the process of forming. Each shape tells a story about its formation history, its interactions with other galaxies, and its ongoing evolution. At the heart of almost every large galaxy lies another cosmic marvel. One we touched upon briefly: a supermassive black hole. These gargantuan objects, millions or even billions of times the mass of our Sun, are intimately connected to the growth and evolution of their host galaxies. The formation of these supermassive black holes is still an active area of research, but it's thought they might have grown by accreting vast amounts of gas and dust from their surroundings, or by merging with other black holes during galactic collisions. The relationship between a supermassive black hole and its host galaxy is a fascinating cosmic ballet. The black hole grows by feeding on the gas in its galaxy. And in turn, the energy released by the black hole's activity can regulate star formation in the galaxy, either triggering it or, in some cases, blowing gas away and suppressing it. It's a dynamic, intricate feedback loop that shapes the very destiny of galaxies. Our own Milky Way galaxy is a beautiful example of this galactic evolution, born billions of years ago. It has steadily grown by merging with smaller galaxies and drawing in vast reservoirs of gas. We live in one of its graceful spiral arms, a quiet corner far from the bustling galactic center, where a supermassive black hole known as Sagittarius A silently reigns. Millions of times more massive than our Sun, the stars you see in the night sky, the familiar constellations, are all part of this vast cosmic island we call home, a testament to billions of years of gravitational assembly and stellar evolution. As the universe continues its relentless expansion today, galaxies are still moving apart from each other. However, within galaxy clusters, where gravity is strongest, galaxies are gravitationally bound and often continue to merge and interact. For instance, our own Milky Way is on a collision course with its nearest large galactic neighbor, the Andromeda Galaxy, in about 4.5 billion years. These two majestic spirals will begin a slow, spectacular merger, eventually forming a larger, more elliptical galaxy. It's a cosmic dance that continues, a testament to the ongoing shaping and reshaping of the universe's grand structures. So, as you rest in this quiet moment, allow your mind to envision the grand sweep of galaxy formation. Imagine the subtle whispers of gravity slowly drawing together vast clouds of gas and dark matter, patiently building the cosmic cities of light. See the first chaotic, clumpy proto-galaxies, merging and evolving over eons. Shaped by unseen forces and violent collisions, feel the deep connection to these ancient processes, knowing that every atom in your being has been part of this grand, continuous journey, assembled and reassembled across billions of years of cosmic history. Let the sheer scale and profound beauty of galactic evolution fill you with a sense of wonder and deep peace, gently carrying you further into a state of profound tranquility as the magnificent dance of galaxy formation continues, sculpting the universe into a grand tapestry of light. Let us now shift our quiet contemplation to a phenomenon that emerges from this very process, one that is both profoundly destructive and immensely creative: the life and death of stars. These celestial beacons, each a tiny furnace in the vast darkness, are the true alchemists of the cosmos, tirelessly transforming the simplest elements into the building blocks of planets and, ultimately, life itself. Imagine each star not just as a distant point of light, but as a living entity, born from swirling gas, burning brightly, and eventually fading, leaving behind a legacy that shapes all that follows. The story of a star begins in the heart of a molecular cloud. These are vast, cold, and dense regions of gas and dust, floating silently in the spiral arms of galaxies. Within these immense clouds, perhaps spanning hundreds of light years, gravity begins its patient work. Tiny pockets of gas, slightly denser than their surroundings, start to collapse under their own gravitational pull. This is a slow, gentle process, spanning tens of thousands or even millions of years. As more gas and dust are drawn in, the core of this collapsing cloud becomes denser and hotter, forming a protostar. Think of it as a cosmic embryo, steadily gathering mass and slowly warming up, preparing for its fiery birth. As the protostar continues to contract, the pressure and temperature in its core steadily climb. Eventually, after millions of years of gentle accretion, the temperature and pressure at the very center reach a critical threshold about 15 million degrees Celsius. At this incredible temperature, the nuclei of hydrogen atoms begin to fuse together, forming helium nuclei, releasing an enormous amount of energy in the process. This is nuclear fusion, the very engine that powers a star. At this moment, the protostar ignites, becoming a true star, a beacon of light and heat, and enters the longest and most stable phase of its life, the main sequence. Our own sun is a main sequence star, about 4.6 billion years old, and it will remain in this stable phase for another 5 billion years. During the main sequence, a star is in a delicate balance. The outward pressure from the tremendous energy generated by nuclear fusion in its core perfectly counteracts the inward pull of gravity, creating a stable equilibrium. This balance allows the star to burn steadily for millions, billions, or even trillions of years. Depending on its mass, the mass of a star is the most crucial factor determining its life cycle, its luminosity, and its ultimate fate. Low-mass stars, like red dwarfs, which are much smaller and cooler than our sun, burn their hydrogen fuel incredibly slowly. They can live for trillions of years, far longer than the current age of the universe. They are the cosmic marathon runners, quietly conserving their energy. Intermediate mass stars, like our sun, are middle-aged cosmic citizens. They burn their fuel at a moderate rate and have lifespans of billions of years. High-mass stars, however, are the cosmic rock stars. They are enormous, incredibly luminous, and burn through their fuel at a furious pace. They live fast and die young, their lifespans measured in mere millions of years. As a star exhausts the hydrogen fuel in its core, its stable main sequence life comes to an end, and it begins its transition to old age. What happens next depends dramatically on its initial mass. For intermediate mass stars like our sun, once the hydrogen in the core is depleted, nuclear fusion ceases, and gravity begins to win the battle, causing the core to contract. This contraction heats up the layers of hydrogen surrounding the core, triggering a new shell of hydrogen fusion. The energy from this shell fusion causes the outer layers of the star to expand dramatically and cool, turning it into a red giant. Our sun, in about 5 billion years, will swell to become a red giant, so large that it will engulf Mercury, Venus, and possibly even Earth. It will become a vast, luminous but cooler sphere after the red giant phase. The star's core continues to contract and heat, eventually becoming hot enough around 100 million degrees Celsius to ignite helium fusion, where helium nuclei fuse to form carbon and oxygen. Once the helium in the core is exhausted, fusion completely ceases. The outer layers of the star gently drift away into space, forming a beautiful, expanding shell of glowing gas known as a planetary nebula. These nebulae are some of the most stunning objects in the night sky, ethereal clouds of cosmic material, painting the universe with vibrant colors. At the center of this expanding nebula, all that remains is the incredibly dense, hot, and compact core of the star, a white dwarf. A white dwarf is roughly the size of Earth, but contains the mass of our Sun. Making it incredibly dense, a teaspoon of white dwarf material would weigh tons. It slowly cools over billions of years, eventually fading into a cold, dark black dwarf, a cosmic cinder. The fate of high-mass stars is far more dramatic and violent. These colossal stars, at least 8 times the mass of our Sun, also expand into red supergiants after exhausting their hydrogen fuel. However, their immense gravitational pull allows their cores to reach much higher temperatures and pressures, enabling them to fuse progressively heavier elements. They continue to fuse elements in a series of concentric shells, like an onion, forming heavier and heavier elements, helium into carbon and oxygen, then oxygen into neon, neon into magnesium, and so on, all the way up to iron. Iron is a crucial turning point. Unlike lighter elements, the fusion of iron does not release energy. Instead, it requires energy. Once the core of a massive star is primarily iron, it can no longer generate energy to counteract gravity. The star has reached the end of its nuclear life, without the outward pressure from fusion. The core undergoes a catastrophic, rapid collapse under its own overwhelming gravity. This collapse happens in a fraction of a second, so fast that it bounces off the incredibly dense core, sending a powerful shockwave roaring outwards. This shockwave blasts the star's outer layers into space in a spectacular, immensely powerful explosion, a Type II supernova. A supernova explosion is an event of unimaginable ferocity. For a brief period, a single supernova can outshine an entire galaxy, radiating as much energy as our Sun will emit over its entire 10 billion-year lifespan. These explosions are the primary cosmic factories for creating all the elements heavier than iron, including gold, silver, uranium, and all the precious metals that make up our planet and are vital for life. Without supernovae, the universe would be a much simpler, less chemically rich place. They are the universe's ultimate recycling plants, taking the raw ingredients from the Big Bang and the elements forged in stellar cores, and scattering them across the cosmos, providing the building blocks for future generations of stars, planets, and even us. What remains after a supernova depends on the initial mass of the star. If the leftover core is between about 1.4 and 3 times the mass of our Sun, it collapses into an incredibly dense object called a neutron star. Imagine taking the mass of our Sun and compressing it into a sphere only about 20 kilometers in diameter, the size of a small city. A teaspoon of neutron star material would weigh billions of tons. Neutron stars are essentially giant atomic nuclei, composed almost entirely of neutrons packed incredibly tightly together. They are often rapidly spinning and possess incredibly powerful magnetic fields, sometimes emitting beams of radiation that sweep across space, appearing as pulsars to our telescopes. If, however, the original star was truly massive, more than roughly 20-30 times the mass of our Sun, and the remaining core after the supernova is more than about 3 times the mass of our Sun, then gravity wins completely. Nothing, not even the pressure of degenerate neutrons, can stop the collapse. The core collapses further and further, until all its mass is compressed into an infinitesimally small point called a singularity. This creates the ultimate cosmic enigma, a black hole. A black hole is a region of space-time where gravity is so incredibly strong that nothing, not even light, can escape its pull once it crosses a boundary known as the event horizon. They are the ultimate cosmic devourers. Silent, invisible, and profoundly mysterious. And profoundly so. The life cycle of a star is a continuous ballet of gravity and nuclear fusion. A story of immense power, beautiful creation, and dramatic destruction. From the gentle collapse of a gas cloud to the steady burn of hydrogen, from the graceful shedding of outer layers to the violent brilliance of a supernova. Each star plays its part in enriching the universe. Every atom of carbon in your body, every atom of oxygen you breathe, every atom of iron in your blood, all were forged in the heart of a long-dead star and scattered across the cosmos by a titanic supernova explosion. You are, quite literally, made of stardust, a testament to the endless cycle of stellar life and death. As you allow these images of cosmic birth, life, and death to gently drift through your mind, feel the profound connection to these ancient processes. There is a deep, soothing rhythm in the stellar dance, a silent song of creation and renewal. Let the quiet wonder of these scientific truths, the knowledge that you are intimately woven into this grand cosmic tapestry, gently guide you into a deeper state of peace and relaxation, carrying you further into the quietude of the cosmos, the universe, in its constant cycles of creation and dissolution, offers a gentle reminder of the interconnectedness of all things, an endless flow from which all life emerges, as the majestic cycles of stellar life and death continue to enrich the cosmic canvas, scattering new elements across the vastness. Let us now turn our quiet contemplation to one of the universe's most elusive and perplexing inhabitants, dark matter. Imagine a silent, invisible architect shaping the grand structures of the cosmos without ever revealing its presence directly. It's a mystery whispered through the gravitational pull it exerts, a subtle phantom that holds galaxies together and orchestrates the dance of the largest cosmic structures. For many decades, astronomers observed the visible universe, the stars, the gas, the dust, and used the laws of gravity to understand how these components should move. However, as our instruments became more sophisticated and our observations more precise, a profound discrepancy began to emerge. When scientists looked at how galaxies spun, they found something truly puzzling. The outer regions of spiral galaxies were rotating much faster than could be explained by the gravitational pull of the visible matter alone. If only the visible matter were present, these outer stars and gas clouds should have been flung off into intergalactic space, much like a stone leaving a spinning slingshot. Yet they weren't. They held together, as if gripped by an unseen hand. This was one of the first compelling pieces of evidence for the existence of dark matter. It suggested that there must be an enormous amount of unseen, unheard, and unfelt mass extending far beyond the visible boundaries of galaxies, creating an extra gravitational pull that keeps everything bound together. This invisible halo of matter seemed to dominate the mass of galaxies, dwarfing the contribution of all the stars, gas, and dust we can actually see. The evidence for dark matter didn't stop at galactic rotation curves. When astronomers studied clusters of galaxies, vast collections of hundreds or even thousands of galaxies bound together by gravity, they found even more striking discrepancies. Galaxies within these clusters were moving at incredibly high speeds, far too fast for the visible mass of the cluster to hold them in place. Once again, it was as if an immense, invisible gravitational field was at play, providing the necessary glue to prevent the clusters from flying apart. Another powerful piece of evidence comes from a phenomenon called gravitational lensing. According to Einstein's theory of general relativity, massive objects bend the fabric of spacetime, and light, traveling along this warped spacetime, follows a curved path. Just as a conventional lens can focus or distort light, massive objects in space can act as gravitational lenses, bending the light from distant background galaxies. When astronomers observed distant galaxies whose light was being lensed by foreground galaxy clusters, they found that the amount of bending was far greater than could be accounted for by the visible matter in the cluster alone. The gravitational lensing effect indicated that there was much more mass present than could be seen. Providing a direct map of the invisible dark matter distribution, perhaps one of the most compelling pieces of evidence comes from the bullet cluster, a system formed by the collision of two galaxy clusters. when these two clusters smash through each other. The ordinary matter, the hot gas, which interacts electromagnetically, slowed down due to friction, much like two clouds of smoke colliding. However, the dark matter, which is thought to interact only very weakly, pass straight through each other, largely unimpeded. Observations using X-ray telescopes showed that the hot gas was lagging behind, while gravitational lensing maps clearly showed that the bulk of the mass, the dark matter, had continued onward. Having passed through the collision, this clear separation of visible matter from the gravitating mass was a striking confirmation that dark matter is indeed a distinct and dominant component of the universe. So, what exactly is dark matter? That, gentle traveler, is one of the universe's most profound and enduring mysteries. Despite its overwhelming gravitational influence, dark matter does not appear to interact with light or any form of electromagnetic radiation. It doesn't emit light, absorb light, or reflect light. This is why it's dark. It's not because it's cloaked in shadow, but because it simply doesn't interact with photons. The particles of light, it also doesn't interact strongly with ordinary matter through the strong or weak nuclear forces. If it did, we would have detected it by now in experiments on Earth. The leading hypothesis is that dark matter is composed of entirely new, undiscovered types of fundamental particles. Particles that are not part of the standard model of particle physics, which describes all the known particles and forces. These hypothetical particles are often referred to as WIMPs, or weakly interacting massive particles. Imagine particles that are massive, giving them gravitational pull, but interact so feebly with ordinary matter that they pass straight through us, through the Earth, through stars, without leaving a trace. Billions of dark matter particles could be streaming through your body right now, and you wouldn't feel a thing. Scientists around the world are actively engaged in a tireless hunt for dark matter. They are building highly sensitive detectors deep underground, shielded from cosmic rays, hoping to catch a rare glimpse of a WIMP interacting with an atomic nucleus, perhaps producing a tiny recoil that could be measured. Other experiments are looking for indirect signs of dark matter, such as the gamma rays that might be produced if two dark matter particles were to annihilate each other in dense regions of space, like the Galactic Center and the Large Hadron Collider. The powerful particle accelerator at CERN is also involved, attempting to create dark matter particles in high-energy collisions, though so far without success beyond WIMPs. There are other theoretical candidates for dark matter, each with its own fascinating properties. Perhaps it's a particle called an axon, an incredibly light particle that could have been produced in vast numbers in the early universe. Or maybe it's a more exotic form of mirror matter, a hidden sector of particles that only interact with our universe through gravity. The possibilities are vast, and the search continues. Pushing the boundaries of our knowledge, the existence of dark matter fundamentally reshapes our understanding of the universe's composition. Current estimates suggest that dark matter makes up about 27% of the total mass and energy of the universe. In comparison, ordinary matter, all the stars, galaxies, planets, and everything we can see and touch accounts for only about 5%. The rest, a staggering 68%, is something even more mysterious, which we will explore in our next contemplation, Dark Energy. This means that the universe we perceive, the one filled with dazzling galaxies and shimmering nebulae, is but a tiny fraction of the whole. The vast majority of the cosmos is made of something we cannot see, something we do not yet fully understand. It's a humbling thought, isn't it, that our familiar reality is merely a thin veil over a much grander, mostly invisible reality? Dark matter played a vital role in the formation of galaxies and large-scale structures, without its pervasive gravitational influence. The subtle density fluctuations in the early universe would not have been strong enough to overcome the expansion and clump together to form galaxies. Ordinary matter alone would have simply been too diffuse to coalesce into the intricate cosmic web we observe. Dark matter provided the initial scaffolding, the invisible framework upon which the visible galaxies were built. It was the silent force that gathered the cosmic dust and gas, gently guiding them into the magnificent structures that grace our night sky. As you rest in this quiet moment, allow yourself to contemplate the profound mystery of dark matter. Imagine an unseen presence, silently weaving the fabric of the cosmos, holding everything together with an invisible embrace. Feel the gentle pull of this unknown force, knowing that it surrounds you, permeates all of space, and plays a fundamental role in the universe's grand design. There is a deep, soothing quality to this hidden influence, a silent reassurance that even in the vastness, there are unseen connections that bind everything together. Let the mystery of dark matter, this invisible anchor of the universe, gently guide you into a deeper state of peace and tranquility, drifting further into the quietude of the cosmos as the silent, invisible embrace of dark matter holds galaxies together, weaving its unseen web across the cosmos. Let us now turn our quiet attention to an even more perplexing and dominant enigma: dark energy. Imagine an unseen force, subtle yet pervasive, not pulling things together like gravity, but gently, relentlessly pushing everything apart, accelerating the very expansion of the universe. It's a mystery that stretches our understanding of reality, a silent whisper that hints at a cosmic future far different from what we once imagined. For much of the 20th century, cosmologists generally agreed on the basic narrative of the universe. It began with the Big Bang, expanded rapidly, and then, under the influence of gravity pulling everything together, its expansion would gradually slow down. The big question was whether it would slow down enough to eventually halt and reverse, leading to a big crunch, or if it would continue to expand forever. Slowing asymptotically to a halt, the universe's fate seemed to depend solely on how much matter, both ordinary and dark, it contained. More matter meant more gravity, and thus a greater likelihood of the eventual collapse. Then, in the late 1990s, something truly astonishing and unexpected happened. Two independent teams of astronomers, the Supernova Cosmology Project and the High Z Supernova Search Team, were studying distant type Ia supernovae. These particular types of supernovae are incredibly important in cosmology because they are considered standard candles. This means they all explode with roughly the same intrinsic brightness, making them excellent tools for measuring cosmic distances by comparing their observed brightness to their known intrinsic brightness. Astronomers can calculate how far away they are, and by observing their redshift, how much their light has been stretched by the universe's expansion, they can determine how fast the universe was expanding at different points in cosmic history. What these teams discovered was utterly groundbreaking. They found that distant supernovae were fainter than expected, meaning they were farther away than predicted by a universe whose expansion was merely slowing down. The only way to explain this observation was if the universe's expansion wasn't slowing down at all, but was in fact accelerating. This was a truly revolutionary finding, throwing a massive curveball into our understanding of the cosmos. It was as if you threw a ball into the air, expecting it to slow down and fall, but instead, it started to speed up and fly away even faster. This accelerating expansion implied the existence of a mysterious, unseen force, a form of energy that counteracts gravity and drives space apart. This unknown entity was given the name dark energy. It's dark not because it absorbs light, but because, like dark matter, we cannot directly observe it or understand its nature. It doesn't clump together like matter, but instead seems to be a property of space itself, subtly pushing on the very fabric of the cosmos. Imagine a vast, invisible pressure permeating every single cubic centimeter of empty space, gently pushing everything away from everything else. Unlike matter, whose density decreases as the universe expands, the density of dark energy appears to remain constant, or nearly constant, even as space stretches. This means that as the universe gets bigger, there's effectively more stuff, more space, filled with more dark energy, so its overall influence grows stronger over time relative to the diminishing density of matter and radiation. There are several leading ideas about what dark energy might be, each one more fascinating and perplexing than the last. One possibility is that dark energy is the cosmological constant, first introduced by Albert Einstein himself in his theory of general relativity. Einstein initially proposed this term to allow for a static universe, something he later called his biggest blunder after Edwin Hubble discovered the universe was expanding. However, with the discovery of accelerating expansion, the cosmological constant has made a triumphant return. In this view, dark energy is simply the intrinsic energy of empty space itself, a fundamental property of the vacuum of space. Even when stripped of all matter and radiation, is not truly empty according to quantum mechanics. It constantly bubbles with virtual particles popping in and out of existence. This inherent energy of the vacuum could be the dark energy we observe, exerting a negative pressure that drives acceleration. However, quantum field theory predicts a vacuum energy density vastly, unimaginably larger than what we observe, a discrepancy of about 10^120 times. This is one of the biggest unsolved problems in physics, often called the vacuum catastrophe. Another intriguing possibility is that dark energy is a dynamic, evolving field, not a constant. This hypothetical field is sometimes called quintessence. Imagine a field that changes over time and space, perhaps subtly interacting with other fields or matter. This could explain why dark energy's influence became dominant only relatively recently in the universe's history. It offers a more flexible explanation than a rigid cosmological constant, but it also requires introducing new fundamental particles or forces that we have yet to discover. A third, more radical idea is that dark energy isn't a thing at all, but rather a sign that our understanding of gravity itself is incomplete on cosmological scales. Perhaps Einstein's theory of general relativity, which describes gravity so beautifully on solar system and galactic scales, needs to be modified when applied to the vast, accelerating expanses of the entire universe. This would be a profound shift in our understanding of the fundamental laws of nature, requiring entirely new theoretical frameworks, regardless of its true nature. Dark energy is the dominant component of our universe. Current measurements from the Planck satellite and other cosmological observations indicate that dark energy constitutes about 68% of the total mass energy content of the universe. Dark matter makes up about 27%, and ordinary matter, everything we can see, is a mere 5%. This means that over 95% of our universe is made of something mysterious, something we cannot see, touch, or fully comprehend. It's a truly humbling thought, reminding us how much there is yet to discover about the very reality we inhabit. The accelerating expansion driven by dark energy has profound implications for the ultimate fate of the universe. If dark energy remains constant or continues to strengthen, the universe will continue to expand at an ever-increasing rate. Distant galaxies will recede from us at speeds faster and faster, eventually exceeding the speed of light relative to us, meaning their light will never be able to reach us. The cosmic horizon, the boundary of the observable universe, will shrink, and eventually, all galaxies beyond our local group, the Milky Way and Andromeda, which are gravitationally bound, will vanish from our view. The night sky will become increasingly empty, with only our local galactic neighbors remaining visible. This future scenario is often called the Big Freeze or the heat death of the universe. In this chilling future, billions of years from now, stars will eventually burn out, exhausting their fuel. Red dwarfs, the longest-lived stars, will eventually fade. Black holes, the ultimate cosmic devourers, will slowly evaporate over incredibly long timescales through a process called Hawking radiation. Eventually, even protons, the building blocks of ordinary matter, might decay. The universe would become an incredibly cold, diffuse, and empty void, filled only with the lingering echoes of photons and perhaps a few widely scattered fundamental particles. All energy gradients would be smoothed out, and no more processes could occur. It would be a state of ultimate thermodynamic equilibrium, a cosmic quietude of absolute stillness, a nothingness of activity and structure. However, the nature of dark energy is still fiercely debated, and its influence could change. What if dark energy eventually dissipates or weakens? Or what if it somehow strengthens so much that it tears apart galaxies, stars, planets, and even atoms themselves? In a horrifying scenario known as the Big Rip, these are extreme possibilities, but they highlight the profound impact of this mysterious force on the cosmic destiny. As you rest in this quiet moment, allow yourself to contemplate the profound mystery of dark energy. Imagine an invisible, omnipresent force gently pushing on the fabric of space, quietly expanding the cosmos into an ever greater void. Feel the subtle, almost imperceptible nature of this cosmic engine. Knowing that it silently governs the grand scale of the universe's destiny, there is a deep, soothing quality to this unknown influence. A silent reassurance that, even in the greatest uncertainties, there is a profound order, a quiet rhythm guiding the universe's endless journey. Let the enigma of dark energy, this unseen driver of cosmic expansion, gently guide you into a deeper state of peace and tranquility. Drifting further into the quietude of the cosmos, as the quiet, relentless push of dark energy gently guides the universe towards an uncertain future, expanding the vast cosmic canvas. Let us now turn our contemplative gaze to a concept that seems, at first glance, utterly contradictory to the boundless expanse we've been exploring: nothingness. What does it mean for something to be nothing? Is it merely the absence of everything, a complete void? Or is there a deeper, more profound, and perhaps even active form of nothingness at the very heart of reality? Imagine silence so profound that it hums with potential, an emptiness so complete that it paradoxically contains everything. Our everyday understanding of nothingness usually means an empty space. If you clear a table, it becomes empty, full of nothing. But even that empty space is filled with air, or if in a vacuum, it is still filled with light, or gravitational fields, or even quantum fluctuations. So achieving a true, absolute nothingness, even in our mundane experience, is remarkably difficult. When we delve into the realm of physics, the concept of nothingness becomes far more intricate and fascinating. What was before the Big Bang? That primordial moment of creation. If time itself began at the Big Bang, then asking what came before, it is like asking what is north of the North Pole. It's a question that might not even make sense within our conventional framework of time. But this doesn't fully satisfy our human curiosity, does it? We instinctively seek a predecessor, a cause, even for the very beginning of existence. One profound way to consider nothingness in the cosmic context is to revisit the concept of the vacuum. In classical physics, a vacuum is simply space devoid of matter, but in quantum mechanics, the vacuum is anything but empty. It's a teeming, fluctuating sea of potential, a vibrant foam of energy. According to the Heisenberg uncertainty principle, you can't simultaneously know both the exact position and the exact momentum of a particle. This principle also applies to energy and time. It means that, for extremely brief moments, energy can spontaneously pop into existence from nothing, as long as it disappears just as quickly. This leads to the concept of virtual particles. These are particle-antiparticle pairs that continuously and spontaneously appear out of the vacuum. exist for an unimaginably tiny fraction of a second, and then annihilate each other, returning their energy to the vacuum. They are virtual because they cannot be directly observed or detected in the same way as real particles. But their fleeting existence has measurable effects, such as the Casimir effect, where two uncharged metal plates placed very close together in a vacuum experience a small attractive force due to the subtle differences in virtual particle fluctuations outside and between the plates. So, in the quantum vacuum, nothingness is not truly empty. It's a seething cauldron of virtual activity, a constant bubbling and fizzing of creation and annihilation. It's a dynamic, energetic field filled with latent potential. This perspective suggests that the universe might have, in a sense, emerged from this very quantum foam, a giant quantum fluctuation that somehow grew into the cosmos we inhabit. It's a captivating idea that from this energetic nothing, everything could spontaneously arise beyond the quantum vacuum. The very definition of nothing becomes even more slippery when we consider the universe's origin. If we imagine the universe as a sphere, and time as a path on its surface, then at the south pole of this sphere, time might lose its conventional meaning, and the concept of a singular beginning in time might dissolve. This is an idea explored in the no-boundary proposal by Stephen Hawking and James Hartle. In this speculative theory, the universe doesn't have a sharp, well-defined starting point in time, like a nothing followed by a something. Instead, it describes a universe that emerges from a state where space-time itself is Euclidean, meaning time behaves more like another dimension of space. Without a clear beginning or end, it's as if the universe is a self-contained entity, a closed surface without an edge, where the question of what came before simply doesn't apply in the way we usually think. This perspective challenges our intuitive grasp of causality, suggesting that perhaps the universe didn't come from nothing in the sense of an empty void, but rather that its earliest state was a form of nothing that transcends our linear understanding of time. It's a beautiful, almost poetic, thought, a universe that simply is, without a sharp, jarring point of creation from an absolute void. Furthermore, consider the concept of symmetry. In physics, symmetries are deeply profound. When a symmetry is broken, it can lead to the emergence of different forces or particles. Imagine a perfectly symmetrical nothingness. If this perfect symmetry were to be subtly broken, perhaps by a quantum fluctuation, it could lead to the emergence of distinct fields, particles, and forces, creating the rich complexity of our universe from a simple, underlying state. It's like a perfectly balanced coin, but with an imperceptible bias that, when flipped an infinite number of times, eventually reveals a pattern. The idea that the universe could emerge from nothing is also explored in theories of quantum cosmology, where the universe itself is treated as a quantum system. In this view, the universe could have tunneled into existence from a state of pure potential, a state without classical space-time or matter. It's similar to how a quantum particle can tunnel through an energy barrier, even if it doesn't classically have enough energy to do so, applied to the entire universe. This could mean that the cosmos, in its infancy, quantum tunneled from a state of pure nothing, a complete absence of classical reality, into the initial conditions that led to the Big Bang. So, when we speak of nothingness in the context of the universe, we're not just talking about an empty box. We're talking about a concept that stretches the very fabric of our understanding, a quantum vacuum that is teeming with virtual activity, a speculative origin where time itself might not have had a distinct beginning in the conventional sense, a breaking of perfect symmetries that allowed complexity to emerge, a quantum tunneling event from a state of pure potential. Each of these interpretations suggests that nothingness is not a passive void, but an active, dynamic, and potentially fertile ground from which existence springs. It transforms nothingness from an endpoint into a beginning, from an absence into a source. this profound mystery. This blurring of lines between nothing and everything can be deeply soothing. It reminds us that our conventional ways of thinking are often too limited to grasp the grand scale of cosmic reality. It invites us to release our need for clear-cut answers and embrace the beautiful ambiguity of existence. As you rest in this quiet moment, allow your mind to drift into this contemplation of nothingness. Imagine a space beyond silence, beyond emptiness, a realm of pure potential. Feel the subtle hum of the quantum vacuum, the unseen dance of virtual particles, the profound stillness that cradles the very fabric of reality. There is a deep, soothing comfort in recognizing that even what we perceive as nothing is, in fact, incredibly rich with possibility. Let the mystery of nothingness, this fertile void at the heart of existence, gently guide you into a deeper state of peace and tranquility. Drifting further into the quietude of the cosmos, it is a reminder that even in the deepest stillness, there is a fundamental energy, a boundless potential for creation, a silent whisper of infinite possibility as we gently float through the profound quiet of nothingness. Contemplating its paradoxical richness and potential, let us now allow our minds to drift towards another concept that challenges our intuitive grasp of reality-time. For us, time is a relentless, linear arrow, moving inexorably forward from past to future. We feel its passage in the ticking of clocks, the aging of bodies, the unfolding of seasons. But in the grand cosmic tapestry, is time truly a fundamental, unchanging river? Or is it something far more fluid, far more mysterious? Perhaps even an emergent property of the universe itself. Imagine time not as a single, straight line, but as a vast, shimmering ocean. Sometimes it flows swiftly, like a rushing current. Other times it eddies and swirls, or perhaps even appears to stand still in moments of deep contemplation or intense experience. This intuitive sense of time, however, often diverges from what physics tells us about its true nature. In classical physics, particularly Newton's view, time was seen as an absolute, universal constant, flowing independently of everything else. It was like an invisible, steady rhythm dictating the march of events across the cosmos, whether you were on Earth or a distant galaxy. A second was always a second, and it ticked away uniformly for everyone. This seemed perfectly logical, fitting with our everyday experience. However, the brilliant insights of Albert Einstein profoundly revolutionized our understanding of time. In his special theory of relativity, Einstein demonstrated that time is not absolute but relative. It is inextricably linked with space, forming a four-dimensional fabric called space-time. The rate at which time passes depends on your motion. The faster you move through space, the slower you move through time relative to a stationary observer. This phenomenon, known as time dilation, means that if you were to travel at speeds close to the speed of light, time for you would slow down compared to someone remaining on Earth, while imperceptible in our daily lives. This effect has been precisely measured in experiments, like atomic clocks on airplanes, and is even crucial for the accuracy of GPS systems. So, a moment for you might not be the same length as a moment for someone else, depending on their speed. Then, with his general theory of relativity, Einstein expanded this revolutionary idea further, linking time not just to motion but also to gravity. He showed that massive objects warp the fabric of space-time, and this warping affects the flow of time. The stronger the gravitational field, the slower time passes. This is known as gravitational time dilation. For instance, time passes slightly slower on Earth's surface than it does in orbit, where gravity is slightly weaker, near an incredibly massive object, like a black hole. This effect becomes extreme. As you approach the event horizon of a black hole, time for you would appear to slow down almost infinitely relative to an observer far away. To that distant observer, you would seem to freeze just at the edge. forever suspended, while for you, time would continue its normal pace, carrying you across the horizon into the unknown. These insights reveal that time is far from a simple, independent entity. It is woven into the very fabric of the universe, a dynamic dimension that bends, stretches, and flows differently depending on the distribution of mass and energy. It's not a river flowing through space, but rather a river that is space-time, constantly being sculpted and reshaped by the cosmic landscape. But what about the fundamental nature of time's arrow? Why does time always seem to move forward? From past to future, we remember the past, but we cannot change it. We anticipate the future, but we cannot see it definitively. This is famously known as the arrow of time. The laws of physics, at their most fundamental level, are mostly symmetric with respect to time. They work just as well backward as forward. For example, if you watch a video of billiard balls colliding, the laws of physics describing their motion would be equally valid if played in reverse. Yet, in our everyday experience, time clearly has a direction. The answer to the arrow of time largely lies in the concept of entropy, a measure of disorder or randomness in a system. The second law of thermodynamics states that the total entropy of an isolated system can only increase over time, or remain constant, but never decrease. In simpler terms, systems tend to move from states of order to states of disorder. A broken cup won't spontaneously reassemble itself. Milk and coffee, once mixed, won't unmix. The universe. Having started in an incredibly low entropy state, the highly ordered, hot, dense, early universe has been expanding and becoming more disordered ever since. This increasing disorder, this irreversible march towards greater randomness, is what gives time its apparent direction. It's a macroscopic phenomenon, emerging from the collective behavior of countless particles. Rather than a fundamental property of time itself at the quantum level, this idea leads to a fascinating contemplation. If the universe is always increasing in entropy, then the future is always more disordered than the past. So, the arrow of time is really the arrow of increasing disorder, as long as there is a difference in entropy between two states. We can define a direction of time, however. When we delve into the realm of quantum gravity, the elusive theory that seeks to unify general relativity with quantum mechanics, the concept of time becomes even more profoundly puzzling. Some theories, such as loop quantum gravity, suggest that space-time itself might not be a smooth, continuous fabric, but rather a discrete, granular structure at the very smallest scales, like tiny loops or atoms of space-time. In such a framework, time might not be fundamental at all, but rather an emergent property that arises from the interactions of these fundamental quantum chunks of reality. It's as if time isn't a pre-existing stage upon which events unfold, but rather a pattern that emerges from the play itself. Imagine a universe where time only makes sense when there are distinct events or changes. If there were absolutely no change, no movement, no interaction, would time still exist? Some theoretical models suggest that at the very deepest levels of quantum reality, the concept of time as a linear progression might vanish altogether, only to reappear when the universe reaches a certain level of complexity and interaction. It's a mind-bending thought. Perhaps time isn't a given, but a phenomenon that emerges from the universe's own dance. This profound uncertainty about the nature of time can be incredibly liberating. It invites us to release our rigid grip on a linear, unyielding progression, and to embrace the possibility that time is far more flexible, far more deeply interwoven with the fabric of existence than we typically imagine. It suggests that our experience of time is perhaps just one particular manifestation of a deeper, more fundamental reality. As you rest in this quiet moment, allow your mind to drift into this contemplation of time. Imagine it not as a constant, ticking clock, but as a gentle current, sometimes flowing swiftly, sometimes swirling in eddies, always responsive to the hidden contours of space-time. Feel the subtle elasticity of time, the way it can stretch and contract depending on gravity and motion. There is a deep, soothing comfort in recognizing the intricate and mysterious nature of time. A silent reminder that our reality is far richer and more complex than we often perceive. Let the enigma of time, this fundamental rhythm of the cosmos, gently guide you into a deeper state of peace and tranquility, drifting further into the quietude of the cosmos. In this spaciousness, perhaps the rigid demands of temporal progression can soften, allowing you to simply be, beyond the constraints of past or future, as our minds gently float through the enigmatic nature of time, perceiving its elasticity and its deep connection to the cosmic fabric. Let us now turn our quiet contemplation to a concept that pushes the boundaries of our imagination even further: the multiverse. Imagine our universe, vast and magnificent as it is, not as the entirety of existence, but merely one bubble, one ripple, in an infinite ocean of other universes, each with its own laws, its own history, its own unique unfolding. It's a whisper of boundless possibilities, a profound reassurance that perhaps everything that can happen does happen somewhere, in some cosmic neighborhood. The idea of a multiverse is not just a whimsical fantasy, but a concept that arises naturally from several leading scientific theories. It's a logical extension of our current understanding, a subtle inference drawn from the very mechanisms that govern our own cosmic reality. One of the most compelling origins for the multiverse concept emerges from the theory of cosmic inflation that we discussed earlier. Remember that incredibly rapid, exponential expansion that smoothed out our universe and set its initial conditions? Well, some models of inflation, particularly eternal inflation, suggest that once inflation starts, it never truly stops everywhere. Instead, it continues indefinitely in some regions, while in others, it ends, creating bubble universes that pinch off and inflate on their own. Imagine a vast, endlessly expanding foam. Within this foam, tiny bubbles are constantly forming, expanding, and sometimes budding off new bubbles. Each one of these bubbles is a distinct universe, our own universe being just one such bubble. In this scenario, inflation doesn't just create our universe, but an infinite number of universes, each born from a localized end to inflation. These bubble universes could be truly distinct, perhaps with different physical constants, different particles, or even different dimensions. This makes the multiverse a vast, ever-generating cosmic engine, constantly birthing new realities. Another way the multiverse arises is from quantum mechanics, particularly the many worlds interpretation MWI in quantum mechanics. Particles can exist in multiple states simultaneously, a phenomenon known as superposition. When a measurement is made, the wave function collapses, and the particle is observed in a single state. The many worlds interpretation suggests that instead of the wave function collapsing, every possible outcome of a quantum measurement is realized. But in a different universe, imagine you are faced with a choice, or a quantum event occurs in one universe. You make one decision, or one outcome manifests, but in another parallel universe, a different choice is made, or the other outcome manifests. Every time a quantum event occurs, the universe splits into multiple branches, each representing a different possibility. This means there isn't just one you reading this, but countless versions of you, living out every conceivable permutation of your life in an ever-branching cosmic tree. It's a mind-boggling thought, suggesting an infinite number of parallel realities, each subtly or dramatically different from our own. While this interpretation is highly debated, it offers a fascinating perspective on the nature of reality and the boundless reach of quantum possibilities. Then there is the concept arising from string theory and M theory, highly theoretical frameworks that attempt to unify all fundamental forces. These theories suggest the existence of extra-spatial dimensions beyond the three we perceive, and that our universe might be confined to a brane, a kind of membrane within a higher dimensional space. Sometimes called the bulk Imagine our universe as a two-dimensional sheet of paper floating in a three-dimensional room. Other sheets of paper, other brains, could be floating nearby, each representing another universe. These brains might occasionally collide or interact, perhaps even giving rise to new Big Bangs. In this brain multiverse scenario, other universes could be incredibly close to us in these extra dimensions, yet remain entirely undetectable because our matter and forces are confined to our own brain. It's a tantalizing thought that a whole other universe could be just a millimeter away, but in a dimension we cannot perceive. Finally, we have the idea of a cyclical or oscillating universe. While our current understanding suggests an accelerating expansion, some theories propose that the universe might undergo endless cycles of expansion and contraction. Perhaps a big bounce instead of a big bang from nothing. In such a model, the universe would contract to an incredibly dense state, then bounce back out into a new expansion, potentially creating a new universe with each cycle. Each bounce could reset the fundamental constants, leading to a new iteration of reality. This would mean our universe is just one in an endless series of cosmic rebirths, a continuous cosmic rhythm. The concept of a multiverse often arises in discussions about the fine-tuning problem. Our universe appears remarkably fine-tuned for the existence of life. If the fundamental physical constants like the strength of gravity, the mass of an electron, or the precise energy density of dark energy were even slightly different, the universe would be a very different place. Stars might never form, atoms might not be stable, or carbon, the backbone of life, might not exist. The probability of all these constants aligning perfectly by chance seems incredibly small. One explanation for this apparent fine-tuning is the multiverse. If there are an infinite number of universes, each with slightly different fundamental constants, then it's no longer surprising that we find ourselves in one that is perfectly suited for life. In such a vast landscape of possibilities, a universe like ours is bound to exist. It's like winning the lottery. It's incredibly improbable for any single ticket to win. But if you buy every possible ticket, then winning becomes a certainty. We simply observe the universe that allows for our existence. The implications of the multiverse are profound. It challenges our anthropocentric view, suggesting that our universe is not necessarily special or unique, but simply one iteration among countless others. It opens up the possibility of truly infinite variations, where every possible outcome, no matter how improbable, eventually plays out somewhere. It transforms our cosmic home from an isolated island into a single droplet in an endless ocean. While the multiverse remains a theoretical concept, largely unprovable by direct observation due to the inherent isolation of these hypothetical universes, it offers a powerful framework for thinking about existence. It provides a sense of boundless possibility, a comforting thought that perhaps every potentiality is realized somewhere in the grand cosmic design. It invites us to release the need for our universe to be singular and embrace the vastness of what might be. As you rest in this quiet moment, allow your mind to drift into this contemplation of the multiverse. Imagine countless bubble universes, each a distinct reality, softly shimmering in an unseen expanse. Feel the gentle hum of infinite possibilities, the profound reassurance that somewhere, every version of existence is playing out. There is a deep, soothing comfort in recognizing the boundless nature of reality, a silent reminder that the universe, in its grand design, might be far more expansive and intricate than we can ever fully grasp. Let the enigma of the multiverse, this concept of endless realities, gently guide you into a deeper state of peace and tranquility, drifting further into the quietude of the cosmos. In this profound spaciousness, perhaps the boundaries of your own reality can soften, allowing for a deeper sense of connection to the infinite, as our contemplation gently expands into the infinite possibilities of the multiverse. Embracing the idea that our reality is but one among countless others, let us now bring our focus closer to the very essence of existence that underpins everything we've discussed, the fundamental laws of physics. These aren't merely abstract equations or complex theories, they are the silent, unwavering rules that orchestrate the cosmic ballet, governing every interaction, every movement, from the smallest quantum fluctuation to the grandest galactic collision. Imagine them as the deep, resonant hum that gives form and rhythm to the universe, an invisible harmony guiding all phenomena. Think of these laws as the universe's innate wisdom, the foundational principles upon which all phenomena are built. They are universal, meaning they apply everywhere in the cosmos, from the heart of a distant quasar to the quietude of your own breath. They are consistent, meaning they don't change arbitrarily. The force of gravity that pulls an apple to the earth is the same force that binds galaxies together. And they are often elegant, revealing a profound simplicity and beauty beneath the surface complexity of the universe. One of the most profound and familiar of these laws is gravity. We experience it constantly, keeping our feet on the ground and planets in orbit around stars. In Newtonian physics, gravity was described as a force, an invisible pull between any two objects with mass. It was a simple yet incredibly powerful description that allowed us to understand the motions of celestial bodies for centuries. However, Albert Einstein's theory of general relativity offered a far more elegant and accurate description. Instead of a force, Einstein taught us to see gravity as a manifestation of the curvature of spacetime. Massive objects, like stars and planets, warp the fabric of spacetime around them, and what we perceive as gravity is simply objects following the curves in this warped fabric. Imagine a bowling ball placed on a stretched rubber sheet. It creates a dip, and marbles rolled nearby will curve towards the ball. Similarly, planets orbit the sun not because of an invisible tug, but because they are following the curves in spacetime created by the sun's immense mass. This is a profound shift in perspective, transforming gravity from a mysterious force into a geometric consequence of reality itself. Beyond gravity, we have the other fundamental forces, collectively described by the Standard Model of Particle Physics. This model describes three more fundamental forces. The electromagnetic force is responsible for all interactions involving charged particles. This is the force that binds electrons to atomic nuclei, creating atoms and molecules. It governs all chemistry, all light, all electricity, and all magnetism. Without it, there would be no stable atoms, no complex structures, no life as we know it. It's the force that allows your brain to function, your eyes to see, and your heart to beat. It's a force of attraction and repulsion, creating the vibrant tapestry of matter. Then there are the strong nuclear force and the weak nuclear force, both acting at the incredibly tiny scales within atomic nuclei. The strong nuclear force is the strongest of all fundamental forces, responsible for binding quarks together to form protons and neutrons, and then binding these protons and neutrons together to form atomic nuclei. It is incredibly powerful but acts over extremely short distances, preventing the positively charged protons from repelling each other and flying apart. Without the strong force, there would be no stable atomic nuclei and thus no elements heavier than hydrogen. It's the ultimate glue of the atomic world. The weak nuclear force, while weaker than the strong force, plays a crucial role in radioactive decay and certain nuclear reactions, particularly those involved in stellar processes. It's responsible for processes like nuclear fusion in the sun that convert hydrogen into helium, and for the decay of neutrons into protons, which allows for the creation of heavier elements during supernova explosions. It's a subtle yet vital force, gently guiding the transformations within atomic nuclei. These four fundamental forces: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force govern every interaction in the universe. But what gives particles their mass? This question was answered with the discovery of the Higgs field and its associated particle, the Higgs boson. Imagine the Higgs field as an invisible, omnipresent molasses-like substance that permeates all of space. Particles moving through this field interact with it, and this interaction gives them their mass. Particles that interact strongly with the Higgs field acquire more mass, while those that interact weakly or not at all, like photons, remain massless. The discovery of the Higgs boson at the Large Hadron Collider was a monumental achievement, confirming a crucial piece of the Standard Model and completing our understanding of how fundamental particles acquire their inertia. One of the profound mysteries that physicists continue to grapple with is the quest for a theory of everything towing. A single, unified framework that can describe all these fundamental forces in particles, especially unifying gravity with quantum mechanics. Our current understanding works beautifully in its separate domains, general relativity for the very large and very massive, and quantum mechanics for the very small and very light. But when we try to describe phenomena where both are important, such as the singularity at the heart of a black hole or the very first moments of the Big Bang, our theories break down. This search for a toe is a profound journey into the heart of reality, a quest to find the ultimate simplicity and elegance underlying all complexity. Theories like string theory and M theory are attempts to achieve this unification. They propose that the fundamental building blocks of the universe are not point-like particles, but tiny, vibrating one-dimensional strings or higher-dimensional brains. The different vibrational modes of these strings give rise to different particles and forces, including, tantalizingly, a particle that behaves like a graviton, the hypothetical quantum of gravity. These theories are incredibly complex and often require the existence of extra-spatial dimensions, which are curled up and hidden from our perception, while still highly speculative and unproven. They offer a glimpse into a potentially unified and incredibly beautiful reality. The beauty of these fundamental laws lies not just in their predictive power, but in their unwavering consistency. They allow the universe to operate with a profound sense of order, allowing for the emergence of complexity, from simple atoms to intricate galaxies, from single-celled organisms to conscious beings. They are the silent, unyielding principles that allow stars to burn, planets to orbit, and life to flourish. They are the constants that permit change, the rules that allow for evolution. As you rest in this quiet moment, allow your mind to drift into this contemplation of the fundamental laws of physics. Imagine the invisible threads of gravity, electromagnetism, and the nuclear forces, silently weaving the fabric of reality, orchestrating every interaction with perfect precision. Feel the deep, resonant hum of these universal principles, knowing that they are the very ground of your being, the silent architects of all that is. There is a profound, soothing comfort in recognizing this underlying order, this consistent harmony that permeates the cosmos. Let the elegance of these fundamental laws, these unwavering whispers of cosmic truth, gently guide you into a deeper state of peace and tranquility, drifting further into the quietude of the cosmos in this profound stillness. Perhaps you can feel the subtle, beautiful dance of reality unfolding, guided by these timeless, invisible principles, as our journey through the fundamental laws of physics reveals the elegant, underlying harmony of the universe. Let us now gently turn our contemplation towards a concept that is both deeply familiar and utterly mysterious: consciousness. How does the universe, which began as a swirl of energy and fundamental particles, evolve to produce beings capable of self-awareness, of pondering its own existence, of experiencing joy, sorrow, and wonder? Imagine consciousness not as something separate from the cosmos, but as a subtle, emergent property, a whisper that arises from the universe itself, an intricate melody played on the instrument of matter. From a purely scientific perspective, consciousness is often seen as an emergent property of complex biological systems, particularly the human brain. Our brains are incredibly intricate networks of billions of neurons, each connected to thousands of others, forming trillions of connections. The electrical and chemical signals flowing through these networks, the constant dance of information processing, somehow gives rise to what we call conscious experience. Consider the journey of complexity. In the very early universe, there was only a plasma of fundamental particles. As the universe cooled, atoms formed. Then, through the life and death of stars, heavier elements were forged. These elements then combined to form molecules, some simple, some incredibly complex, on Earth, under specific conditions. These complex molecules organize themselves into self-replicating structures, eventually leading to the first living cells, over billions of years of evolution. These simple life forms diversified and grew in complexity, leading to organisms with nervous systems, and eventually, to brains capable of complex thought. So, is consciousness simply a very sophisticated form of computation? A complex algorithm running on biological hardware? This is a view held by many scientists, suggesting that given enough complexity and the right kind of organization, consciousness naturally arises. It's like how a hurricane emerges from the interaction of countless air molecules, or a symphony emerges from the interaction of musical notes. The whole is greater than the sum of its parts, and consciousness might be that emergent whole. However, this scientific perspective doesn't fully capture the subjective, qualitative aspect of consciousness, often referred to as qualia. Why does red look red? Why does pain feel painful? Why do we experience subjective emotions and sensations? These are the hard problems of consciousness, the aspects that are difficult to explain solely in terms of physical processes. It's one thing to describe the neural activity in the brain when someone sees red. It's another to explain why that neural activity produces the subjective experience of redness. This leads to deeper, more philosophical questions. Is consciousness confined to biological brains, or could it exist in other forms? Could sufficiently complex artificial intelligence eventually become conscious? These are questions that push the boundaries of our understanding, inviting us to consider what truly defines awareness. Perhaps consciousness isn't just a byproduct of complex matter, but something more fundamental, something woven into the very fabric of the universe itself. This idea is explored in concepts like panpsychism, which suggests that consciousness, or at least proto-consciousness, is a fundamental property of matter, present in all things, perhaps even at the level of elementary particles. It's not that a rock is conscious in the way a human is, but that there is an irreducible, basic form of experience or information processing, even at the most fundamental levels of reality. From this perspective, human consciousness would be a highly complex and integrated form of this ubiquitous proto-consciousness. Imagine a vast, interconnected web of faint awareness, slowly blossoming into the profound self-awareness we experience. Another intriguing idea is the role of quantum mechanics in consciousness. Some theories, highly speculative but fascinating, propose that quantum phenomena occurring within the brain's microtubules, tiny structures within neurons, might play a role in conscious experience. While mainstream neuroscience largely views consciousness as a classical emergent property, the idea that the strange, non-local, and superpositional nature of quantum reality might somehow contribute to the mystery of consciousness is a captivating one. It suggests a deeper connection between the microcosm of quantum reality and the macrocosm of subjective experience. Consider the universe's long journey from simplicity to complexity. It's as if the cosmos has been steadily experimenting, building increasingly intricate structures, from fundamental forces to particles, from atoms to molecules, from stars to galaxies, and finally, from simple life to complex brains capable of self-reflection. Is consciousness the universe's way of looking back at itself, of becoming aware of its own existence, are we, in a profound sense? The universe's eyes and mind, this perspective offers a deeply comforting and awe-inspiring thought. If consciousness is indeed an emergent property of the universe's complexity, then our own awareness is not an isolated phenomenon, but a direct continuation of the cosmic story. We are not separate from the universe, but an intimate part of its ongoing unfolding, a localized expression of its vast, evolving potential. Your ability to think, to feel, to wonder about the stars and the depths of space is a testament to the universe's own capacity for self-awareness. This understanding can lead to a profound sense of connection, a gentle merging with the grand narrative of existence. It suggests that the quiet moments of introspection, the deep breaths of relaxation, the very act of pondering these cosmic mysteries are all part of the universe's gentle awakening in your moments of stillness, of quiet contemplation. You are participating in the universe's own journey of self-discovery, a silent dialogue between the cosmos and itself. As you rest in this quiet moment, allow your mind to drift into this contemplation of consciousness. Imagine the universe not just as inert matter, but as a vast, evolving entity, capable of birthing awareness. Feel the subtle spark of your own consciousness, knowing that it is intimately woven into the grand tapestry of cosmic evolution. There is a profound, soothing comfort in recognizing that your very being is a testament to the universe's capacity for wonder, a silent whisper of its unfolding awareness. Let the enigma of consciousness, this ultimate mystery of existence, gently guide you into a deeper state of peace and tranquility, drifting further into the quietude of the cosmos in this profound connection. Perhaps you can feel the universe breathing with you, a silent, shared awareness in the boundless expanse. As our quiet contemplation of consciousness gently brings us to the profound realization that the universe itself might be gazing back through our eyes. Let us now turn to a concept that both grounds us in the present moment and stretches our understanding of cosmic influence, the interconnectedness of all things. Imagine not just separate entities existing side by side, but every particle, every force, every whisper of energy inextricably linked, forming a single, vast, pulsating web of existence. It's a silent, undeniable truth woven into the very fabric of reality. A gentle reminder that nothing truly exists in isolation. From the very first moments of the Big Bang, the universe was a single, unified entity. All the matter and energy that would ever exist were compressed into an infinitesimal point. As it expanded and cooled, different forces separated, particles formed, and structures emerged. Yet the memory of that initial unity, that primordial connection, remains. Every atom in your body, every star in the sky, every galaxy in the distant cosmos, originated from that same singular point. We are, quite literally, all made of the same stardust, forged in the hearts of ancient stars and scattered across the universe, only to be drawn back together in new and intricate forms. Consider the fundamental forces we discussed earlier: gravity, electromagnetism, and the strong and weak nuclear forces. These aren't just separate phenomena, they are constantly interacting, shaping and influencing each other. Gravity dictates the large-scale structure of the universe, pulling galaxies together, but it is the electromagnetic force that allows atoms to form and stars to shine. The strong force holds atomic nuclei together, but its action ultimately contributes to the stellar processes that release the energy that drives the weak force in nuclear reactions. Each force plays its part, and together, they orchestrate the grand cosmic symphony. No single force acts alone. They are a seamless, interacting dance. Think about the cosmic web, that vast, intricate network of galaxies, clusters, and superclusters strung together by filaments of dark matter and ordinary gas, punctuated by immense, empty voids. This web is not just a random scattering of galaxies, but a testament to the interconnectedness of matter on the largest scales. Galaxies are drawn to each other by gravity, merging and interacting, exchanging gas and stars. What happens in one part of a galactic cluster can influence distant members. The universe, at its largest scale, resembles a giant brain, with threads of matter and energy forming interconnected pathways, even at the smallest scales. The principle of interconnectedness holds profound sway in quantum mechanics. Phenomena like entanglement beautifully illustrate this. When two particles become entangled, they become linked in a peculiar way, regardless of the distance separating them. If you measure a property of one entangled particle, you instantaneously know the corresponding property of the other. Even if it's light years away, it's as if they share an invisible, instantaneous connection, defying our classical understanding of space and time. This spooky action at a distance, as Einstein called it, suggests a deep, non-local interconnectedness woven into the very fabric of reality at its most fundamental level. What happens to one affects the other instantaneously across vast cosmic distances. This interconnectedness isn't just a physical phenomenon, it extends into the realm of our own existence and experience. Every breath you take connects you to the entire planet, sharing the same atmosphere, the same air that has passed through countless living beings throughout history. The water you drink has cycled through oceans, clouds, and living organisms for billions of years. The food you eat draws its energy from the sun, processed through the intricate web of life on Earth. You are, in a very real sense, a microcosm of the universe, a temporary assembly of cosmic material, intricately linked to everything around you. Your thoughts and feelings, too, are part of a larger interconnected network. While consciousness might emerge from individual brains, our experiences, emotions, and ideas are shared, influenced, and shaped by our interactions with others. With culture, with history, there is a collective human consciousness, a vast pool of shared knowledge and experience that we all draw upon and contribute to. Even the act of reading these words creates a subtle connection between your mind and the ideas woven into this narrative. A gentle resonance across space and time. The understanding of interconnectedness can be incredibly soothing and empowering. It dissolves the illusion of separation, reminding us that we are not isolated islands, but vital threads in an immense, beautiful tapestry. It fosters a sense of belonging, a profound realization that we are part of something far grander than ourselves, intimately woven into the universe's continuous unfolding. When you feel alone, remember the countless cosmic threads that bind you to every star, every atom, every moment of existence. This realization can also inspire a deeper sense of responsibility and compassion. If everything is interconnected, then our actions, however small, ripple outwards, affecting the whole. The gentle kindness you extend to another, the quiet contemplation you engage in, the peacefulness you cultivate within yourself all send subtle vibrations through the cosmic web, contributing to the overall harmony of existence. It's a reminder that every individual note contributes to the grand symphony. As you rest in this quiet moment, allow your mind to drift into this contemplation of interconnectedness. Imagine invisible threads of energy and information weaving through all of space and time, connecting you to every star, every galaxy, every particle that has ever existed. Feel the subtle hum of this universal connection, knowing that you are an integral, irreplaceable part of this vast, living cosmos. There is a profound, soothing comfort in recognizing this unity, this silent truth that nothing is truly separate. Let the enigma of interconnectedness, this boundless web of existence, gently guide you into a deeper state of peace and tranquility, drifting further into the quietude of the cosmos. In this profound sense of unity, perhaps all feelings of isolation can dissolve, leaving only a quiet, gentle embrace with the whole of reality. As our minds gently absorb the profound interconnectedness of all things, recognizing the subtle threads that weave together every part of the cosmos, let us now conclude our quiet journey with a contemplation of the cosmic future. Having explored the universe's fiery birth, its majestic evolution, its unseen components, and the very nature of time and consciousness. What lies ahead for this vast, ever-unfolding reality? Imagine the universe not as a static painting, but as a grand narrative still being written, its final chapters stretching into unimaginable depths of time. Our understanding of the cosmic future is largely shaped by the mysterious force we explored earlier, dark energy. Remember, it's the dominant component of our universe, silently pushing space apart, causing the expansion of the cosmos to accelerate. If dark energy continues to behave as a cosmological constant, a stable, unchanging property of space itself, then the universe is headed towards a future known as the Big Freeze, or the heat death of the universe. In this scenario, billions upon billions of years from now, the accelerating expansion will continue to drive distant galaxies further and further away from us, faster than the speed of light relative to us. This means their light will eventually be stretched beyond detection, and they will effectively vanish from our observable universe. Our cosmic horizon will shrink, leaving our local group of galaxies, the Milky Way, Andromeda, and their smaller companions as an isolated island in an ever-darkening, expanding void. Imagine peering into the night sky, and instead of countless distant galaxies, you see only the stars within our own small galactic neighborhood, surrounded by an infinite, impenetrable blackness within our isolated local group. The gravitational dance will continue. Our Milky Way and the Andromeda Galaxy are already on a collision course, and in about 4.5 billion years, they will begin a slow, majestic merger, eventually forming a larger, more elliptical galaxy, this new galactic entity, sometimes playfully called Milkomeda, will be a cosmic monument to gravitational attraction, a final large-scale structure in our isolated corner of the universe. But even within Milkomeda, the stars, though incredibly long-lived, are not eternal. Over trillions of years, all the stars will eventually exhaust their nuclear fuel. The smallest stars, the red dwarfs, will burn for trillions of years, far longer than the current age of the universe. But even they will eventually fade, cooling into cold. Dark black dwarfs, mere cosmic cinders in the vast expanse. Larger stars will have long since exploded as supernovae, leaving behind neutron stars or black holes. Once all the stars have burned out, the universe will become an increasingly cold, dark, and empty place. The remaining stellar remnants, white dwarfs, neutron stars, and black holes will continue to orbit each other for unimaginable timescales, occasionally interacting or merging. Planetary systems will eventually be disrupted, their planets either ejected into the interstellar void or spiraling into their dying central stars or black holes, over even longer, truly mind-boggling timescales. The very fabric of matter might begin to decay if protons are not absolutely stable. As some grand unified theories suggest, they could eventually decay into lighter particles and radiation, though the predicted timescales for this are extraordinarily long. Perhaps 1034 years or more, a number so vast it's almost meaningless. If proton decay does occur, then even the last remnants of ordinary matter will eventually vanish, leaving behind only fundamental particles and light, scattered thinly across an ever-expanding, increasingly cold, and empty universe. Finally, the ultimate fate in the Big Freeze scenario is thermal equilibrium, also known as heat death. This doesn't mean extreme heat, but rather the absence of any temperature differences. All energy gradients will have been smoothed out, meaning there will be no more available energy to do work. No processes will occur, no interactions will happen. The universe will be a cold, diffuse, and utterly still void, a state of ultimate randomness and maximum entropy, where nothing ever changes. It'll be the grand cosmic quietude, a profound and eternal silence. However, it is important to remember that the nature of dark energy is still one of the greatest mysteries in physics. While the cosmological constant is the leading candidate, other possibilities exist. and they paint very different pictures of the cosmic future. What if dark energy isn't constant, but actually strengthens over time? This could lead to a catastrophic scenario called the Big Rip. In this extreme possibility, the accelerating expansion would become so intense that it would eventually overcome even the forces holding galaxies together. Then stars, then planets, and finally, even atoms themselves, tearing apart everything into its most fundamental constituents. This would be a violent, abrupt end, a cosmic shredding. Conversely, what if dark energy dissipates or reverses its effects? Some theories suggest that the universe could eventually begin to contract again, leading to a big crunch, a reversal of the Big Bang, where all matter and energy collapse back into an infinitely hot, dense point, or perhaps in a cyclical universe. This collapse would lead to a big bounce, initiating a new Big Bang and a new cosmic cycle. For now, the Big Freeze remains the most widely accepted fate based on our current observations of dark energy. It is a future of gentle dissipation, of gradual cooling, of slow fading into an eternal quietude. It speaks to the ultimate triumph of entropy, the slow march towards ultimate equilibrium. Yet, even in this seemingly bleak cosmic destiny, there is a profound beauty and a gentle peace. The universe, in its final state, might become the ultimate meditation, a state of perfect stillness, where all activity ceases and only pure potential remains. It is a reminder of the transient nature of all things, even galaxies and stars, and an invitation to find peace in the cyclical unfolding of existence, our own lives, our joys and sorrows, our triumphs and challenges, our fleeting moments within this grand cosmic drama. But they are also incredibly precious, vibrant bursts of activity against a backdrop of cosmic quietude. As you rest in this final quiet moment of our journey, allow your mind to drift into this contemplation of the cosmic future. Imagine the vast, silent expanse, stretching into unimaginable depths of time, slowly transforming, gently fading. Feel the profound stillness of ultimate equilibrium, the quietude that embraces all things. There is a deep, soothing comfort in recognizing this grand narrative, this endless unfolding, knowing that your own existence is a vibrant, intricate part of this cosmic dance. Let the enigma of the cosmic future, this ultimate quietude, gently guide you into a deeper state of peace and profound tranquility, inviting you to simply be in harmony with the boundless, evolving cosmos. As our gentle exploration of the universe's grand narrative comes to its quiet close, having drifted through its birth, its evolution, and its ultimate destiny, let us now arrive at a final, deeply personal contemplation, the beauty of cosmic uncertainty and the peace of not knowing. In our human lives, we often crave certainty, a firm grasp on answers, a clear path forward. Yet the universe, in its boundless wisdom, whispers a different truth, that much of its profound beauty lies precisely in its mysteries. In the vast expanse of what we do not yet comprehend, imagine the universe not as a textbook to be memorized, but as an endless, enchanting poem, where the most captivating verses are those yet to be fully deciphered. We have touched upon so many profound enigmas in our journey. What truly sparked the Big Bang? What is the elusive nature of dark matter that sculpts galaxies with invisible hands? What is the true identity of dark energy? Silently accelerating the cosmic dance, is there a vast multiverse beyond our own? Stretching into infinite possibilities. What is the fundamental nature of time that flows so differently depending on gravity and motion? And how does consciousness, this miraculous awareness, emerge from the silent workings of the cosmos? For most of these grand questions, the universe offers not definitive answers, but tantalizing clues, elegant theories, and boundless opportunities for wonder. This embrace of the unknown is a profound act of liberation. In our quest for knowledge, We often seek to conquer uncertainty, to fill every void with a fact. But what if the voids themselves hold a deeper truth? What if the spaces between our understanding are precisely where the most profound sense of awe resides? It is in the face of these vast, cosmic unknowns that our imagination truly takes flight. Where our sense of wonder is most deeply stirred, consider the act of stargazing. When you look up at the night sky, you see millions of stars, each a distant sun, but what you are truly seeing is largely the unknown. You are seeing light that has traveled for thousands, millions, even billions of years, carrying stories from a past so remote it feels like a dream. You are seeing structures whose formation is still being pieced together by patient scientists. And beyond the visible, you are gazing into the realm of dark matter and dark energy, the overwhelming majority of the cosmos, which remains profoundly hidden from our direct perception. There is a unique tranquility in resting within this uncertainty. It releases the pressure to have all the answers, to grasp every concept perfectly. Instead, it invites you to simply experience the grandeur of the universe, to feel its vastness, its mystery, its silent unfolding. It encourages a gentle curiosity, a patient willingness to explore without the demand for immediate resolution. This cosmic perspective can be deeply soothing for the human mind, often burdened by the anxieties of everyday certainties and uncertainties. When you find yourself troubled by the small, immediate worries of life, take a moment to recall the vast, elegant unknowns of the cosmos. Does it truly matter if you don't know the precise nature of dark energy, or if string theory accurately describes reality? The universe continues its grand dance regardless, and in that vastness, your personal worries can often shrink into their proper cosmic scale. The peace of not knowing is not an invitation to ignorance, but a pathway to a different kind of wisdom. It is the wisdom of humility, recognizing the limits of human comprehension in the face of infinite complexity. It is the wisdom of openness, staying receptive to new ideas and revelations as science continues its tireless journey of discovery. And it is the wisdom of presence, allowing yourself to be fully immersed in the wonder of the moment, rather than constantly striving to intellectually conquer every mystery. In this embrace of uncertainty, you find a gentle resonance with the universe itself. The cosmos does not present itself as a closed book, but as an eternal question, an unending journey of exploration, and in that perpetual unfolding, there is a profound sense of peace. The universe does not demand that you understand it fully. It simply invites you to experience it, to be a part of its silent, magnificent flow. So, as these words gently fade, and you drift deeper into the quietude of your being, carry with you the gentle whisper of cosmic uncertainty. Let it be a source of calm, a soft blanket woven from the fabric of the unknown. Allow yourself to rest in the vast, elegant questions that the universe poses, finding comfort not in answers, but in the boundless beauty of mystery itself. This is a space where your mind can wander freely, unburdened by the need to define or categorize, simply floating in the limitless ocean of cosmic potential. As our minds gently settle into the quiet understanding of cosmic uncertainty, finding peace in the vastness of the unknown, let us now allow our thoughts to drift to the very essence of universal harmony and balance. Imagine the cosmos not as a chaotic explosion of events, but as an intricately woven tapestry, where every thread, every color, every subtle shift contributes to a breathtaking equilibrium. It's a silent, profound dance between opposing forces, a gentle reminder that even in the grandest scales of existence, there is an inherent elegance, a meticulous interplay that ensures continuity and order. Consider the delicate balance that defines so many aspects of our universe. We have already touched upon the precise fine-tuning of the fundamental physical constants. If gravity were infinitesimally stronger, the universe might have collapsed back in on itself before stars and galaxies could form. If it were weaker, matter might never have coalesced, leaving a diffuse, featureless void. If the strength of the electromagnetic force or the masses of particles were even slightly different, stable atoms might not exist, or the complex chemistry necessary for life would be impossible. This remarkable precision, these almost impossibly narrow windows of possibility, hint at an underlying cosmic wisdom, a foundational balance that allows for complexity and consciousness to emerge. Then there is the profound tension between expansion and gravity. The universe is constantly expanding, pushing everything further apart, driven by the mysterious dark energy. Yet, within this expansion, gravity works tirelessly to pull matter together, forming galaxies, stars, and planets. It is this dynamic interplay, this constant push and pull, that sculpts the universe into the intricate cosmic web we observe. Without the accelerating expansion, the universe might have become a crowded, unstable place, prone to collapse. Without gravity, everything would dissipate into an uninteresting, uniform emptiness. Their opposition creates the very stage upon which the cosmic drama unfolds, a testament to balance in action. Think about the life and death of stars. They are born from contracting clouds of gas, fueled by nuclear fusion, a battle between the inward crush of gravity and the outward pressure of light and heat. When they die, especially in the violent brilliance of a supernova, they scatter the heavier elements forged within their cores across the cosmos. These elements then become the building blocks for new stars, new planets, and new life. It's a grand cycle of creation and destruction, a cosmic recycling program that ensures the continuous renewal and enrichment of the universe. The death of one star is the birth of countless possibilities, maintaining a vibrant, dynamic balance of matter and energy, even within the smallest particles. We find an exquisite balance. The proton, a fundamental building block of atomic nuclei, is incredibly stable, resisting decay for timescales far exceeding the age of the universe. This stability is crucial, for if protons were unstable, all matter would quickly disintegrate, and the universe would be an empty sea of radiation. This durability, balanced against the fleeting existence of other, less stable particles, ensures that matter can persist and form complex structures. Consider the balance between matter and antimatter, as we explored. At the universe's birth, there was almost a perfect symmetry between them, but a tiny, almost imperceptible imbalance. One extra particle of matter for every billion particle-antiparticle pairs allowed matter to triumph, creating the universe we know. This subtle asymmetry, this quiet tilt of the scales, made existence itself possible. It was a cosmic stroke of genius, a moment of perfect imbalance that led to a grand, enduring balance of existence. This concept of balance extends to the very structure of space-time itself. Our universe appears remarkably flat on large scales. This flatness, as inflation theory suggests, is a state of perfect balance between open and closed geometries. A curved universe would lead to vastly different cosmic destinies. But our flat universe, poised precisely between too much and too little curvature, allows for the long-term expansion and the formation of the complex structures we observe. It's like walking a tightrope across an infinite abyss, maintaining a breathtaking equilibrium. The recognition of this universal harmony can be deeply soothing. It reminds us that despite the apparent chaos or vastness of the cosmos, there is an underlying order, a profound elegance that governs everything. It suggests that even in our own lives, finding balance is not just a personal endeavor, but a reflection of a fundamental cosmic principle: the interplay of light and shadow, joy and sorrow, activity and rest. These are all part of the larger balance that shapes our experience. This quiet contemplation invites you to find your own point of equilibrium, to feel the gentle sway of cosmic balance within your own being. When life feels out of sync, or when challenges appear overwhelming, recall the grand, unwavering harmony of the universe, the push and pull of forces, the cycles of creation and dissolution. The delicate fine-tuning all speak to a deep, inherent wisdom that ensures continuity and flow. As you rest in this quiet moment, allow your mind to drift into this contemplation of universal harmony and balance. Imagine the cosmos as a perfectly tuned instrument, each note playing its part in an endless, beautiful symphony. Feel the gentle equilibrium between opposing forces, the subtle precision that allows everything to exist and evolve. There is a profound, soothing comfort in recognizing this cosmic dance, this silent truth that permeates every fiber of existence. Let the enigma of universal harmony, this boundless balance of reality, gently guide you into a deeper state of peace and tranquility, drifting further into the quietude of the cosmos in this profound sense of equilibrium. Perhaps you can feel your own being settling into a natural state of rest, in perfect resonance with the universe's enduring peace, as we gently immerse ourselves in the quiet understanding of universal harmony. Recognizing the delicate balances that orchestrate the cosmos, let us now turn our contemplative gaze inward, towards the profound concept of the universe within you. Imagine that the vastness, the mystery, and the elegance of the cosmos are not merely external phenomena, but are intimately reflected in your very being. A microcosm mirroring the grand macrocosm. It's a silent, gentle truth that you are not just in the universe, but you are the universe, experiencing itself. Consider the atoms that compose your body. Every single atom of carbon, oxygen, nitrogen, and iron within you was forged in the fiery hearts of ancient stars, born in their nuclear furnaces and scattered across the cosmos in spectacular supernova explosions. The hydrogen atoms in your water, in your very DNA, were created in the Big Bang itself. You are, quite literally, made of stardust and the primordial essence of the universe. The elements that built you have traveled across unimaginable distances, through billions of years of cosmic history, finally assembling themselves into the unique constellation that is you. Think about the scale of your own existence in relation to the universe. Within your body, countless cells are constantly working in perfect, synchronized harmony, each a tiny universe unto itself. Neurons fire, chemical reactions unfold, and intricate biological processes maintain the delicate balance of life. And within each cell, within each atom, there are particles dancing, forces interacting, mirroring the grand cosmic ballet on an infinitely smaller scale. The principles of interconnectedness, of balance, of energy transformations that govern galaxies, also govern the silent, continuous processes within your own being, your brain. That marvelous organ of consciousness is perhaps the most astonishing reflection of the cosmos within you. The intricate network of neurons, with its trillions of connections, resembles the cosmic web of galaxies, each node communicating, influencing, and creating complex patterns, just as the universe generates stars and galaxies. Your brain generates thoughts, emotions, memories, and dreams. It is the universe's most complex known instrument, capable of not only observing the cosmos but also contemplating its own existence within it. The very act of wondering about the Big Bang or dark energy is the universe pondering itself through the unique lens of your consciousness. Consider the concept of time as it relates to you. Your own life unfolds in a linear progression, from past to future, yet within you. Memories of the past reside, shaping your present and influencing your future. You experience the relativity of time in moments of joy or boredom, when time seems to stretch or contract, and in moments of deep meditation or profound peace. You can transcend the conventional ticking of the clock, entering a timeless space of pure awareness, echoing the potential timelessness at the very edge of the universe's beginning. The darkness and light within you also mirror the cosmos. Just as the universe contains both luminous stars and vast, dark voids filled with unseen dark matter and dark energy, so too does your inner world encompass both clarity and mystery. known thoughts and unconscious depths, the periods of quiet introspection, the moments of stillness, are like your personal dark ages, periods of integration and unseen growth that precede new understanding and new light. Embracing the idea that the universe is within you is not merely a poetic metaphor, it is a profound scientific and philosophical truth. It suggests that your existence is not separate from the cosmos, but an intimate, integral part of it. You are not a spectator gazing upon a distant universe, but an active participant, a living, breathing expression of its ongoing evolution. Your capacity for wonder, your drive to explore, your ability to feel and connect, these are all reflections of the universe's own inherent nature. This realization can bring a profound sense of peace and belonging. When you feel small or insignificant in the face of the universe's immensity, remember that you are that immensity. The same cosmic forces that sculpt galaxies flow through your veins. The same primordial stardust that ignites stars resides in every cell of your body. There is no separation, only a continuous, flowing connection. You are a unique and precious manifestation of the cosmos. A singular point of awareness where the universe experiences its own magnificent dance. This quiet understanding allows you to release any feelings of isolation or detachment. You are deeply interwoven into the grand fabric of existence. The rhythm of your breath is the rhythm of the cosmos. The beat of your heart echoes the pulse of distant stars. In recognizing this profound unity, you can find a deep, unshakable tranquility, a sense of being perfectly at home in the vast, mysterious, and beautiful universe. As you rest in this final quiet moment of our shared journey, allow your mind to drift into this contemplation of the universe within you. Imagine the swirling galaxies, the vast nebulae, the silent dance of particles, all contained within your own being. Feel the profound connection to every atom, every star, every moment of cosmic history that has led to your existence. There is a deep, soothing comfort in recognizing this intimate unity, this silent truth that you are a living, breathing part of the universe's magnificent unfolding. Let the enigma of the universe within you, this boundless reflection of reality, gently guide you into a deeper state of peace and profound tranquility, inviting you to simply be, in perfect harmony with the cosmic whole. As our journey through the cosmic reflections within us draws to a close, and we find a deep peace in being one with the universe, let us now softly turn our contemplation to the most universal and profound of experiences, the rhythm of rest and renewal. Just as the cosmos breathes in vast cycles of creation and cessation, expansion and quietude, so too does all of existence, including ourselves. Follow a natural, inherent rhythm of activity and stillness. Imagine the universe not just as a grand, unfolding story, but as a gentle, breathing entity, inviting us to harmonize with its timeless pulse. Consider the universe's own profound cycles of rest and activity. There are moments of intense, explosive creation, like the Big Bang itself, or the birth of new stars in brilliant nebulae. And then there are vast epochs of quiet waiting, like the Dark Ages, where gravity patiently gathered gas, or the immense future of the Big Freeze, where cosmic activity will slowly dissipate into a state of ultimate stillness. Galaxies collide and merge in spectacular fashion, only to settle into new, often more serene, configurations. Black holes devour matter in furious bursts, yet largely exist as silent, immense gravitational anchors. The universe itself demonstrates a profound balance between periods of dramatic action and stretches of quiet, perhaps almost imperceptible. Transformation. This cosmic rhythm is mirrored everywhere we look, on our own planet. We witness the daily cycle of day and night, a fundamental rhythm that governs almost all life. The vibrant activity of day gives way to the gentle quietude of night, a time for rest, repair, and the unseen processes of renewal. The Earth itself spins, constantly cycling through light and shadow, reminding us of the incessant, yet balanced, motion that defines our reality. Then there are the grander cycles of the seasons. Spring bursts forth with new life and energy, followed by the abundance of summer, the gentle decline of autumn, and finally, the deep rest and hibernation of winter. Each season plays its vital role, contributing to the overall health and balance of the ecosystem. Without the quiet, introspective period of winter, the vibrant growth of spring might not be possible. Nature itself understands the profound necessity of cessation, of letting go to make way for new beginnings. Even the smallest forms of life follow this rhythm. Plants grow, bloom, and then shed their leaves or seeds. Returning their energy to the soil, microorganisms flourish and then become dormant, waiting for conditions to change. It is a universal dance of growth and retreat, of energy expenditure and replenishment, and so it is with you. 2. Your own body and mind are intimately attuned to this cosmic rhythm. Your sleep is your personal journey into the deepest form of rest and renewal. It is a time when your conscious mind can quiet down, allowing your body to repair, your memories to consolidate, and your creative spirit to be refreshed. Just as the universe enters its dark ages or its heat death, in cosmic terms, you enter the quiet, restorative darkness of sleep, a necessary period of cessation from conscious activity, when you allow yourself to truly rest, to deeply relax. You are not simply doing nothing. You are engaging in one of the most fundamental and vital processes of existence. You are harmonizing with the universe's own deep breath, its long, slow inhale and exhale. It is in these moments of stillness that the deepest transformations often occur. Much like the silent gathering of dark matter that eventually birthed galaxies, embracing this rhythm of rest means letting go of the constant need for activity, for productivity, for noise. It means allowing your mind to drift freely, unburdened by demands or expectations. It means trusting that just as the universe knows how to balance its grand forces, your own being knows how to find its natural state of equilibrium and renewal. There is a profound wisdom in surrender, in allowing the gentle current of existence to carry you where you need to be, the quiet moments of contemplation we have shared. These gentle explorations of cosmic ideas are themselves a form of rest for the mind. They invite a slower pace, a deeper introspection, a release from the rapid-fire demands of daily life. They are a reminder that true understanding often comes not from striving, but from allowing, not from forcing, but from receiving. As you continue to drift, imagine yourself as part of this boundless, breathing cosmos. Feel the gentle rhythm of rest and renewal flowing through you, connecting you to the earth, the stars, and the deepest mysteries of the universe. This inherent balance, this cyclical dance, is a source of profound peace. It reassures you that after every period of exertion, after every moment of light, there is a natural, necessary return to quiet, to darkness, to the nurturing embrace of stillness, preparing you for whatever new dawn may arrive. As our gentle contemplation of universal rhythms brings us to a deep appreciation for rest and renewal, mirroring the cosmos itself, let us now softly conclude our cosmic journey by embracing the quiet invitation to wonder and stillness. Imagine the universe not as a puzzle to be solved, but as an endless, enchanting mystery to be quietly experienced. It's a silent, profound invitation to simply be, to find peace in the vastness of the unknown, and to recognize the inherent tranquility that underpins all existence. Throughout our shared moments, we have drifted through unimaginable scales of time and space. We've touched upon the fiery birth of the Big Bang, the silent scaffolding of dark matter, the accelerating push of dark energy, and the elusive nature of time itself. We've considered the possibility of multiverses beyond our comprehension and recognized the profound reflection of the universe within you. each concept, each whisper of cosmic truth, invites not a frantic search for answers, but a gentle opening to awe. The universe does not demand that you fully grasp every scientific principle or that you resolve every paradox. Its deepest beauty often lies in its inexplicable nature, in the questions it poses that stretch the very limits of our imagination. The silence between the stars, the vast empty spaces between galaxies, are not voids of absence, but realms pregnant with potential, humming with unseen energies and undiscovered truths. This quiet invitation encourages a different kind of engagement with reality. Instead of striving, pushing, or demanding, it suggests a gentle surrender. It's about letting your mind wander freely, unburdened by the need to categorize or define. It's about allowing the sheer scale and mystery of the cosmos to wash over you, soothing any anxieties and bringing a profound sense of perspective. Your worries, no matter how pressing they feel, are but fleeting whispers in the vast, eternal breath of the universe. Consider the act of listening to silence. True silence is rarely empty. It often contains a subtle hum, a distant echo, a profound sense of presence. Similarly, the stillness of the cosmos is not inert. It is teeming with unseen activity, with particles interacting, with forces at play, with galaxies slowly drifting apart. To embrace stillness is to become attuned to this deeper reality, to recognize that, even in cessation, there is a vibrant potential. This is a space where you are invited to simply breathe. Feel the gentle rise and fall of your chest, connecting you to the Earth's atmosphere, to the ancient cycles of air and life. Let each breath be a conscious act of release, letting go of tension, of striving, of the noise of the day, and with each exhale, imagine yourself dissolving further into the quiet vastness of the cosmos, becoming one with its unending peace. The beauty of this invitation lies in its non-judgmental nature. There is no right or wrong way to experience this wonder, no test to pass, no goal to achieve. It is simply an offering a tranquil space for your mind to rest, for your spirit to wander, for your being to reconnect with the fundamental quietude of existence. Whether these cosmic thoughts gently guide you towards the soft shores of sleep, or simply leave you with a lingering sense of peace and wonder, the purpose is fulfilled. You are a remarkable expression of this very universe, a fleeting yet precious moment of cosmic awareness. Your capacity to wonder, to feel, to experience stillness is a reflection of the universe's own profound nature. In this quiet moment, recognize that you are held within the boundless embrace of the cosmos, cradled by its mysteries and soothed by its eternal rhythms. There is a deep, abiding peace in being exactly where you are, exactly who you are. At this very moment in the universe's grand story, as these words gently fade into the background, and you drift deeper into the quietude of your being, carry with you this gentle invitation. Let the wonder of the cosmos be a lullaby for your thoughts, its stillness a soft blanket for your soul. May you find profound peace in the boundless mystery and deep rest in the eternal quiet. This is not medical advice and does not replace any medical treatment or diagnosis. If you have any health concerns, please consult a healthcare professional. As our cosmic journey draws to its gentle conclusion, having embraced the universe's quiet mysteries and found peace in its boundless rhythms, let us now arrive at our final contemplation, the enduring power of hope and renewal. Even amidst the vast uncertainties and the eventual heat death of the cosmos, the universe continuously whispers a profound truth that within every ending lies the seed of a new beginning, and that cycles of transformation offer an infinite wellspring of possibility. Imagine the universe not just as a grand narrative, but as an eternal symphony, where silence and crescendo endlessly intertwine, always hinting at the next beautiful movement. Throughout our exploration, we've witnessed countless examples of cosmic renewal, The Big Bang was not just an explosion, but the birth of all matter and energy, a singular moment of infinite potential emerging from what might have been nothingness. Stars, after living their brilliant lives, don't simply vanish, they die in spectacular supernovae, scattering the very elements that become the building blocks for new stars, new planets, and new life. This is the ultimate recycling program, where death fuels rebirth and destruction becomes the catalyst for creation. Even the concept of the multiverse, though theoretical, offers a boundless well of hope. If our universe is just one of many, constantly bubbling into existence, then the possibilities for different realities, different expressions of physical laws, and different outcomes are truly infinite. It suggests that even if our particular cosmic story reaches a quiet, cold end, the grand narrative of existence continues endlessly in other realms, a perpetual genesis of new beginnings. Consider the resilience of life on Earth. From the earliest single-celled organisms, life has endured mass extinctions, dramatic climate shifts, and immense geological changes. It has adapted, evolved, and found new ways to flourish, demonstrating an extraordinary capacity for renewal and transformation. This inherent drive to persist, to find pathways for continuation, is a powerful reflection of a deep universal principle. This cosmic perspective invites us to embrace hope not as a naive optimism, but as a recognition of the universe's fundamental nature. Hope, in this context, is the quiet confidence that even in the face of endings, whether personal or cosmic, there is always the potential for new forms, new connections, and new meanings to emerge. It's the understanding that transformation is constant, and that every moment of stillness or dissolution is merely a pause before a different kind of unfolding. Renewal isn't always a dramatic, visible event. Sometimes it's a subtle shift, an inner turning, a quiet letting go that creates space for something new to grow. Just as the universe experiences its dark ages of seemingly inactive expansion before the first stars ignite, our own lives contain periods of quiet introspection, of deep rest, that are essential for future growth and illumination. These moments are not empty. They are fertile grounds for silent renewal, for gathering strength, for the unseen work of transformation. The very act of contemplating the cosmos, of allowing your mind to wander through its vastness and mysteries, is a form of renewal for your spirit. It lifts you beyond the immediate, the mundane, the ephemeral, and connects you to something timeless and enduring. It reminds you that you are part of an immense, ongoing story, and that your existence, however fleeting, is a vibrant contribution to the universe's continuous unfolding. As we reach the very end of this shared journey, carry with you the gentle whisper of this enduring power. Let the cycles of the cosmos, birth and death of stars, expansion and contraction, light and shadow, remind you of the continuous flow of existence, a current that carries all things towards new horizons. May you find profound peace in the knowledge that even in stillness, even in the vast uncertainties, the universe is always moving towards a quiet, beautiful form of renewal. As our long, tranquil journey through the cosmos gently concludes, and we rest in the quiet embrace of hope and renewal, let us now come to our final, deepest contemplation, the profound peace found in surrender. Imagine the universe not as a force to be controlled or understood exhaustively, but as an immense, flowing river, and you, a tiny leaf upon its surface. True serenity often comes not from battling the current, but from allowing yourself to be carried by its gentle, unwavering flow throughout our cosmic exploration. We've touched upon forces and scales so vast they defy our everyday comprehension. We've seen how the universe began from an unimaginable point, expanded rapidly, and continues to be shaped by unseen dark matter and dark energy. We've contemplated the birth and death of stars, the endless march of time, and the possibility of infinite realities beyond our own. In the face of such grandeur and mystery, our human capacity for control or definitive understanding seems beautifully, wonderfully small. This contemplation invites you to release the constant human impulse to grasp, to define, to categorize, to control. So much of our daily anxiety stems from our desire to manage every outcome, to predict every turn, to have an answer for every question. Yet, the universe, in its boundless wisdom, operates on principles far beyond our immediate command. It doesn't ask for your control. It asks for your presence. Surrender, in this cosmic context, is not about giving up or becoming passive. Rather, it is an active, conscious choice to trust the deeper currents of existence. It is about acknowledging that there is a vast, intricate intelligence at play, a fundamental order that orchestrates galaxies and quantum particles alike. It is the peace that comes from knowing you are part of a grander design, a part of the universe's own unfolding. Without needing to direct every step of that unfolding, think of how nature operates. A tree does not strive to grow, it simply grows, drawing sustenance from the soil, light from the sun, and moisture from the air, surrendering to its inherent nature. A river does not force its way, it flows, finding the path of least resistance, carving canyons over eons through the simple act of yielding. This natural wisdom, this quiet surrender to what is, allows for profound and beautiful transformations to occur. For your own well-being, embracing surrender can be incredibly liberating. It means allowing yourself to let go of what you cannot change, to release the burden of expectations, both your own and others. It means accepting the flow of life with a gentle openness, rather than resisting its inevitable ebbs and flows. When you truly surrender, you make space for clarity, for intuition, and for a deeper sense of peace to emerge from within. This is a space where you are invited to fully release. Release tension from your body, allowing it to soften and relax. Release the racing thoughts from your mind, letting them drift away like clouds in the vast cosmic sky. Release any need to be somewhere else, or to be doing something else. Simply be here, now. In this moment of profound stillness and peace, the universe, in its infinite embrace, holds no judgment. It simply is. And in aligning yourself with that fundamental state of being, you can find a deep, unshakable tranquility. You are not battling against the cosmos, you are flowing with it. You are not separated from its mysteries, you are contained within them. As these words gently fade, allow yourself to simply rest. Let the quiet invitation to wonder, the peace of not knowing, and the boundless power of renewal gently carry you into a state of deep surrender. Find comfort in the profound understanding that you are held, you are part of, and you are flowing with the vast, mysterious, and eternally peaceful universe. May this deep sense of surrender guide you into the most profound and quiet rest. This is not medical advice and does not replace any medical treatment or diagnosis. If you have any health concerns, please consult a healthcare professional. What aspects of the universe's grand narrative resonated most deeply with your sense of peace? As our journey through cosmic surrender brings us to a deep and quiet peace, recognizing our place within the vast flow of existence, let us now gently turn our contemplation to the most personal and profound of all cosmic connections, the universe's gentle presence in your daily life. Imagine that the grandeur, the mystery, and the underlying harmony of the cosmos aren't just distant concepts, but subtle, comforting whispers woven into the very fabric of your everyday experience. It's a silent truth. The universe isn't somewhere out there. It's here, within you, around you, in every moment. Consider your breath. Each inhale is a drawing in of molecules that have been cycling through Earth's atmosphere for billions of years. Molecules that may have once been part of ancient stars, primeval oceans, or the breath of countless living beings. Your exhale, in turn, releases those molecules back into the great cosmic dance. This simple rhythmic act of breathing connects you directly to the continuous, life-giving processes of the entire planet and, by extension, the universe's grand cycles of matter and energy. It's a constant, gentle reminder of interconnectedness. Look around you, at the ordinary objects that fill your space. The metal in your phone or furniture was forged in the heart of a long-dead star, scattered across space in a supernova, and eventually coalesced into our planet. The electricity that powers your lights or devices flows through principles of electromagnetism, one of the universe's fundamental forces. The very colors you perceive are light waves, traveling across space from the sun or an artificial source, interacting with your eyes through precise cosmic laws. Everything you see, touch, or use is a testament to the universe's alchemical creativity. Even the passage of time in your daily routine reflects cosmic principles. The rhythm of day and night, of waking and sleeping, is dictated by Earth's rotation, a celestial dance around its axis and its star. Your sense of memory, of past and future, mirrors the universe's own arrow of time, forever moving towards increasing entropy. When you pause to recall a cherished memory, you are, in a small way, engaging with the universe's own vast memory, its historical unfolding etched into the fabric of space-time. Think about the silent forces at play around you. Gravity, that unseen pull, anchors you to the Earth, keeps objects in place, and silently orchestrates the motion of planets. The weak and strong nuclear forces, though imperceptible, bind the atoms in your body, allowing you to exist as a stable collection of matter. The universe's fundamental laws are not abstract theories confined to textbooks. They are the active, ever-present architects of your immediate reality, your very emotions and thoughts. 2. Can be seen as microcosms of universal states. Moments of clarity and insight can feel like sudden bursts of cosmic light. Periods of confusion or challenge can resemble the universe's dark ages. Periods of unseen transformation, your capacity for connection, for empathy, for love, reflects the deep interconnectedness that binds all matter and energy in the cosmos. Your consciousness, as we explored, is the universe experiencing itself? A continuous dialogue between the grand and the intimate. Embracing the universe's gentle presence in your daily life is a profound way to cultivate peace. It transforms the mundane into the miraculous, the ordinary into the extraordinary. It dissolves the illusion of separation, reminding you that you are always, intimately, held within the boundless embrace of the cosmos. There is no need to travel to distant galaxies to feel connected. The connection is here, now, in every breath, every object, every moment. This realization invites a sense of gratitude for the intricate dance of forces and elements that allows your existence. It encourages a quiet reverence for the everyday, seeing the universal in the particular when you feel overwhelmed or disconnected. Simply pause. Take a deep breath and allow yourself to feel the subtle, profound presence of the universe flowing through you, anchoring you and gently holding you. As these words softly fade, and you drift deeper into the quietude of your being, carry with you this gentle awareness. Let the universe's pervasive, comforting presence be a lullaby for your thoughts, its silent harmony a soft blanket for your soul. May you find profound peace in the boundless mystery, and deep rest in the eternal quiet, knowing the cosmos is always intimately with you